Hello my friends, HM here. HM Experience discusses and investigates topics that importantly matters for whether the future of humanity will be better or worse. Today's video entertains the idea that Elon Musk's SpaceX is uniquely positioned to make an ecosystem of drone weapons with autonomous ability that are further augmented by a space-based system of spy and communication satellites also developed and operated by SpaceX. Now, if you think that sounds interesting, you're in for a treat. You may also stock up with some coffee and a cookie jar because it's going to be a long video. With that said, let's get to it. Now, I've organized my video here as a PowerPoint presentation, and I've called it SpaceX could make revolutionary war drones and help protect the free world against tyranny. So let's take a look at the chapters I've included in this presentation. The first one is I'd like to answer the question briefly, do a better future require better weapons? Because that's related to the content of my channel, that I want to talk about things that importantly matters for creating a better or worse future. And then I go to the topic here, telling about the Iranian Shahed drones, because it's actually that drone that has inspired me to make this video and got me thinking about how it could be made better. And I'm going to have another chapter here about why this Shahed drone is so great. It's also, by the way, the picture you see here up, that is the Shahed drone. But SpaceX can make it much better. And that's the fourth chapter, why is SpaceX uniquely positioned to make the Shahed drone even more revolutionary. And then I'll go on to talk about target acquisition and evaluation and how much you can actually see from space for doing this stuff. And I have a lot of pictures to show you there. And then I'm going to discuss how inexpensive autonomous drones will revolutionize modern warfare. And then I'll talk about why SpaceX should be making drone weapons and spy satellites. And then I'll have some concluding remarks. So chapter 1 is, do a better future require better weapons? And the short answer to that question is that a better future do not require better weapons if humanity was only composed of good people and countries that only interacted with other people and countries based on voluntarily and mutually beneficial understandings and agreements. In a world with only good people and countries, no war would ever happen and weapons would really not be needed. Problem is, humanity has many evil people and countries that are willing to exploit other people and countries against their will, using violence and weapons to force these people and countries to do things that they would otherwise not do. And Russia trying to steal people and land from Ukraine using military force is a great example of a mostly evil country trying to exploit a mostly good country. And I'm deliberately using the word mostly evil and mostly good because it's my opinion that we all contain a bit of evil and a bit of good in us, and you can of course struggle with yourself how to suppress your own evil tendencies and how to promote your good intentions. But I don't think we can say that there are some people walking around here that are pure good or pure evil. We are more complex than that, and that's why I'm using this mostly expression here. And I think also the hard reality is that countries that are mostly good, they need more and better weapons than mostly evil countries, or else these mostly good countries would be conquered and exploited by the mostly evil countries. The mostly evil countries will go to war the instant they judge they have a good chance of winning, so that the cost and risk of war is less than the spoil from conquering other people and territory. And mostly evil countries will have no empathy for their victims or the suffering of their own soldiers who are ordered to war. And you may say, well, that's your opinion, I don't believe in that. But then you could ask yourself a simple question. Do you really think that Putin or his inner circle actually care about the suffering of the Ukrainian people and also the suffering of the Russian army that are ordered to do all this killing and horror in Ukraine? Do you really think they care about that? No, they do not. That's what makes them evil, or mostly evil, because it's not everything they do, even in Russia, that is bad. They have also created a lot of economic growth previously in Russia, but right now they're mostly occupied with evil stuff. And it's my belief here that the only way for mostly good countries to prevent war and not getting attacked is to have more and better weapons than the countries that are mostly evil. And I don't think anyone likes this answer, to prevent war and preserve peace, that you need a really strong army. But I think it's the truth, and I think history is evidence that it is the truth. This is also why I think that SpaceX, being a company that's incorporated in a mostly good country, aka United States of America, with a mostly good CEO, aka Elon Musk, can help to create a better future for humanity by making superior weapons in defense of mostly good countries like NATO and Ukraine. And then you can say, well, but Elon Musk, he's not good. He sometimes says some evil stuff. Yeah, but this is my philosophy, that you cannot expect that any of us are entirely good. I was disappointed when I heard Elon Musk proposed a peace proposal for Ukraine that almost sounded like it was out of the playbook from Russia. And I thought that was bad judgment, and that made me doubt that he was all good. And also another thing he have said recently that disappointed me enormously is that he thought that Taiwan should be part of China, and that's how that conflict should be solved with China. I think it should be up to the Taiwanese people to decide themselves whether they will be part of a Chinese country or not. And quite frankly, I don't think they want to be part of China, because they have democracy and free speech in Taiwan, and people in China do not have that. They live actually in an authoritarian state, and Taiwan does not. So I'm pretty sure that Taiwan will not voluntarily join China. But anyway, of course, if they do it someday, go for it. Nobody should prevent an mutually, voluntarily merger of China and Taiwan. But it should definitely not be forced. That's my opinion. And I also think that's Musk's opinion. Maybe he just said it because, he wants to protect his investments in China. Because I think the minute he say that Taiwan should not be Chinese, then they'll just take his factory in Shanghai, and that'll be the end of Tesla in China. So that might be the reason. Now, before we end this chapter here, I'd like to mention two quotes that I found that captures what I'm talking about quite well. And the first quote here is from Edmund Burke, who said, "The only thing necessary for the triumph of evil is that good men do nothing." I thought that was a powerful way of stating it. And another quote here I found, that's from Ronald Reagan. And I hope that all the Democrats watching this in the United States don't shut down and say, I don't want to hear what that man said because he's a Republican. That's how I don't hope that the world will develop. We should listen to each other in a democracy, because even though you don't agree with everything a person said, maybe there's something that person said that you can agree with. And I really hope that we can all agree with this statement here. We know only too well that war comes not when the forces of freedom are strong, but when they are weak. It is then that tyrants are tempted. I think that's very true. Okay, that's the end of this chapter. Then I have a slide with some sources and attribution, and I'll have these slides throughout my presentation because I have to, for legal reasons, I have to give attribution to images and stuff I've used. And I also want to provide you with the sources so you can check for yourself all the things that I'm claiming to be true. I have links where I found that information and you can follow it up. With that said, let's go to chapter 2. What is the Shahed drone? Let's first start by looking at the drone specifications. The Shahed is an attack drone made by an Iranian company called HESA, and officially entered service in the Iranian army in December 2021. But actually the Shahed specs and also the look of this drone is very similar to an Israeli drone called Harpy that was made back in 1989. And there's a picture down here of it. And I believe that this company, Israeli company who made this drone, actually sold blueprint for it back in 2005 to an Iranian company. So they have been then using that to develop this Shahed drone, and maybe the Israelis shouldn't have sold that blueprint. But I guess the Iranians would have figured it out anyway, because it's not that complicated to build this drone. Current Iranian production capacity is 150 units per month. And the buyers of it now is Russia, that has bought 2,400 of them for use against Ukraine. But they haven't gotten them all at once. Iran could give them what they had in stock, and then they're giving them batches as they produce more of them. The weight of this drone is 200 kilo with a 45 kilo warhead, which is pretty big warhead. And why this drone is dangerous. For comparison, the HIMARS warhead is 120 kilo and the rocket is 300 kilo. The HIMARS is an American-made rocket launcher system that Ukraine has used with great success in the war because it's a precision weapon. But this Shahed is also a precision weapon, also uses GPS. The size of the Shahed is 3.5 meters long and a wingspan of 2.5 meters wide. Again, for comparison with HIMARS, that's 22.7 centimeters wide and nearly 4 meters long. And the flight height for the Shahed is between 60 and 4,000 meters. The 4,000 meters is important because at that height, most anti-aircraft guns cannot reach it. The cruising speed is not high, it's 185 kilometers per hour. The HIMARS speed for comparison is 3,062 kilometers per hour. And that's one of the reasons that the Russians haven't been able to shoot it down. It simply fires very fast and it's very hard to hit with an anti-aircraft rocket. Whereas the Shahed is much easier to hit because it's so slow. The range of this Shahed is 1,000 kilometers. And it has been postulated that it can even be 2,500 kilometers. I think if there's any truth to that, I don't think there is. Then of course could only be done with a much smaller warhead. The HIMARS range is 70 kilometers for the version Ukraine got, so significantly shorter range. Then the propulsion of this Shahed drone, and also I'll talk a little bit about frame and body, because it's important for understanding why it costs so little to make. The propulsion is a low-tech propeller design using an old combustion engine, 50 horsepower engine developed by Volkswagen that used it in the Volkswagen Beetles from 1936 to 2006. So it's a very old and very tested design that served Volkswagen well, and now it serves the Iranian army. And this engine there has actually been available from China. China produces this engine and they sold it on a website, but it has gone black from that website. You can no longer find it. But it shouldn't be a difficult engine to remake in an alternative factory. So I'm sure that both Russia and Iran can remake that engine. It'll just be more expensive for them than if they could order it from China. The Iranian Shahed frame and body use a lot of composite materials that are not suited for mass production of this drone by the tens or even hundreds of thousands per month. And you can see it uses composite body from this fragment of the wing here that has broken off in a pattern that only can be from composite materials. Had it been built by metal sheets, it would have been twisted and not look like this. So a design that uses stamped metal sheets and also a metal frame, that is needed if you want to mass produce this drone here by the tens or hundreds of thousands per month. And a metal drone would of course have higher weight, so the range will take a toll. And I would estimate that if you do it in metal, the range will go down from the 1,000 that was possible with the Iranian drone to probably 600 kilometers. But Iran's need for range is higher, and that might explain why they have used a composite body, because Iran's arch enemy is Israel, and Iran would like to strike Israel. So they probably had a requirement for the engineers when they designed this drone that it should have a really long range. And then I have some sources, attribution for previous slides. Let's take a look at the takeoff. So the Iranian Shahed drone allegedly takes off using an expendable solid propelled rocket mounted below. You can see the mount here, and you can see in this picture that there's a rocket exhaust here, and it kind of flies directly out of a truck here. But I think one improvement that could be done by SpaceX that would be better than this rocket-propelled launcher system is to make a catapult launcher that is powered by a powerful electric motor that is winding up a pull cable for the drone. Of course, it has to be a very powerful motor because the drone is 100 kilo and you need to accelerate it to 185 kilometers per hour within, say, 6-7 meters. But it's doable, and such a catapult would save costs because you wouldn't need the launch rocket, and also has a much smaller thermal signature because spy satellites can pick up the heat from a rocket launch, and the enemy could use that to pinpoint your location and start counterfiring on it. My suggestion would be that this electric catapult launcher system would need to fit a standard 40-foot shipping container for minimizing battlefield logistic hurdles, and I think that should be easily doable. It's also very important to think about logistic whenever you design a product, a war machine, that it's also easy to maintain and operate from a logistic point of view, because wars are sometimes won by great logistics and not so much by other things. And then another improvement that SpaceX could do with this drone is that they could have an alternative launch mode that could be using simply a landing gear that also mounts on the same mount that the rocket is mounted on. And that landing gear could either be used for launching, of course, the drone on a paved road just by starting the engine and let it roll along that road and then let it take off. And if it has a landing gear, it can of course also land, so it can be reusable. Well, that's a very useful feature of having a landing gear option. But it could also, if range is really important and you don't expect it to be reused, then you can just drop off the landing gear right after launch to have maximum range. Then I have this little video here I'll show you about how the Iranian Shahed presumably is taking off. So here we have it. It comes up from this truck. Here you can see it a little better. And here it actually attacks something, and you can see it's a very powerful explosion. Okay, and then we reach chapter 3. Why is the Shahed drone so great? The first thing that is so obvious is the low manufacturing cost of this drone compared to other weapons. Shahed only weighs 200 kilo. And it's far simpler to build than a cheap automobile that weighs like 1.2 ton if it's made in metal like an automobile. I'd estimate that a 200 kilo composite drone like the Iranian one, that's likely distributed with those 45 kilo for the warhead that we know about, and then perhaps 100 kilo for the fuel, and then 55 kilo that would be the remaining weight, and that's for building the drone itself. And if you make it in metal, it's more likely that, okay, we'll still have a 45 kilo warhead and it will still be 200 kilo for the total drone loaded with fuel, but then it will have only 60 kilo of fuel. So that's why I estimate, it goes from 1,000 kilometers of range when it's into composite to about 600 kilometers in range if you make it in metal, because it has 40% less fuel. And then the rest of the drone will be 95 kilo for the drone itself. Well, I've made an estimate that the Shahed drone will cost about $60,000 in low volume production when it's mostly hand built. And that's the Iranian version. The reason is composites takes a lot of time to build. You have to make a form, then you have to put some textile, carbon fiber or some other fiber in that form, and then you pour over some resin, liquid resin, and then you have to bake that resin for it to harden, and it just takes a lot of time. It can take hours to make a single sheet. Now I want to show you how this can be done if you do it in an automotive factory style like shown here. Here we have an assembly line with a lot of robots and these cars are just running through here and they're being assembled and welded together by all these robots. And down here we have a little video that shows how a stamping press are making the sheets that could go on the side of the car or that could make up the wings of this Shahed. So let's look at that. here it goes in the sheet, it's pressed, and then a few seconds later it comes out in its shape. So this goes really fast, and that's really affordable to make stuff like that. It will take hours to do the same thing in a composite material. And that's why I think the cost can go down to $6,000 if you make it like an automobile in metal. So that's 1/10 the price of what the Iranians are using. But you also need to produce, in order to set this kind of production up, you need to produce a lot of units, or you won't be able to pay for the cost of all these expensive robots and stamping presses and stuff. So you need to make a lot of them. Iran only make about 150 per month. But in this car manufacturing thing here, you'd have to make 30,000 per month. That would be 12 months a year. Then let's take 2 months out of the year for factory shutdowns and retooling and stuff. That's 10 months with 30,000. That's 300,000. That's mass production for a car manufacturing factory. And they can even be bigger than that. They can also do 60,000 units per month. So you can definitely build a similar style factory making these Shahed drones in metal, and then get the price down to about $6,000, because a cheap automobile, you can build that for about, I don't know, $20,000, or that's the cheapest cars out there, and they're much more complex and will cost a lot more to manufacture. I have actually made a YouTube video before. It's my number 4 video that goes a little more deep into the cost of making the Shahed and the engineering. I'm not going to talk more about that in this video, because then there'll be too much overlap between these videos. So if you're super interested in cost and engineering, then go watch this video. Next slide. So why is the Shahed drone great? Let's compare it with some of the other costs. If you have no idea what things cost, then this will be an eye-opener. So the cost of a Shahed, SpaceX made Shahed with 600 kilometers range and 45 kilo warhead and a speed of 185 kilometers per hour. It'll be about $6,000. And let's compare that to a cruise missile, a standard US cruise missile. There's a picture of it here. It's called a Tomahawk cruise missile. It has 1,600 kilometers range. It has a 450 kilo warhead, so 10 times that of the Shahed. And it flies at 913 kilometers per hour. But it also costs $2 million. And you can get 333 Shaheds for the same price as one Tomahawk missile. Even if you say, okay, but the warhead is 10 times faster, so we'll have to divide this thing here with 10, you can still get 33 Shaheds for every one Tomahawk you fire. So I'd say it has a lot more destructive power, the Shahed, than a Tomahawk missile, simply because of the numbers. You can buy a lot more of them. But of course, a Tomahawk missile is not obsolete. It has longer range. It's also harder to shoot down because it flies at a much higher speed at 900 kilometers per hour. Then let's compare it to HIMARS, and there's a little picture here of this, the HIMARS system that the Ukraine has used successfully in their war against the Russians. It's a US-made rocket, and it only has 70 kilometers range, but it has a 120 kilo warhead, and it flies at a much higher speed, almost 3,100 kilometers per hour. That's very fast. And so far, the Russians have not been able to shoot it down using their SAM anti-aircraft missiles. They can't shoot it down. But it cost $110,000, or the same as 18 Shaheds. Here you could also say, well, the warhead is like 3 times larger, almost 3 times larger. So divide those 18 Shaheds with 3. You'll still be, for the same bang, you can still get 6 times more Shaheds than you can get this HIMARS missile. Plus, the Shahed will have a range of 600 kilometers. This one only flies 70 kilometers. That doesn't mean the Shahed will replace the HIMARS. The HIMARS will still be in demand. In fact, I think we'll use a lot more of them in the future, because they have some advantages. You cannot shoot them down. You can shoot the Shahed down, and also the Shahed is slow. So if you want to destroy a target you have identified, and it has to be now, then you can fire a HIMARS if it's within the range of that HIMARS. Speed is sometimes very important in war. So it's not going to be obsolete, that weapon, because of a lot of cheap Shaheeds. But then there's another weapon here. That's the cost of a 155mm guided Excalibur artillery round with 70 kilometers range. It's a heavy artillery shell, and it's fired by a howitzer like this one. I think that's a Panzerhauser 2000, the German thing, but that can fire that shell. And 70 kilometers range is a lot, because it's actually a self-propelled shell. So you fire it out of this gun, plus it has some self-propulsion. But that also means that the weight of the explosives in that grenade is only down to about 4 kilo. So it's 1/10 of the bang of the Shahed, and also range is far less. And then it costs $68,000 for this shell. That's enough to buy 11 Shaheeds. But it is guided. This Excalibur round is guided, is GPS guided, so it can hit its target. But still, Shahed can also hit its target, and it's far more range, and it's a far bigger bang. So the next one here is the cost of a 155mm standard artillery shell. That will be typically a 43 kilo shell, and that it will have 7 kilo of explosives. Again, you can say, why so little explosives? It's because it comes out of this barrel here with 3,100 kilometers, so just as fast as this HIMARS rocket, even faster. And it needs a lot of metal to keep itself together and not detonating the dynamite that's inside the shell. So it's mostly metal, and it's not guided. This shell here, it's completely dumb. It's just a shell, and then you have a fuse that determines how it explodes. It could be a proximity fuse, so with a little radar in it. So when it's 10 meters or something above its target, it explodes. Or it could be simply a pressure fuse that has to hit something, the ground or a vehicle or something, and then it explodes. Because it's not guided, you have to shoot a lot of them to actually hit something. I'd say you have to shoot about 100 before you hit something at that distance of 30 to 40 kilometers that it can actually shoot. So 100 times $1,000 for each shell, that's about $100,000 to hit something. And that again is, you can buy 17 Shaheeds for that. That has a much bigger bang, because they have this 45 kilo warhead, and most of that will be dynamite, because they don't need a lot of metal in that warhead, because they're not shot out of a gun barrel, so that they don't need a lot of metal to keep the shell together and prevent it from exploding. And then we have the final thing I want to talk about is tanks and tank rounds. NATO tanks, they use a 120mm shell, and typical tank shell cost about $4,000. Then you can say, why does a tank shell cost $4,000? That's more expensive than the $1,000 for a bigger shell for the heavy artillery. It's because tank shells are typically armor piercing, so they're made a little special with some directional explosion that shoots out a plasma that can go through a lot of armor. So they're a little more complicated to build. That's why they're more expensive. And then again, I estimate you need to fire about 10 times before you actually hit a target with a tank shell. So that would be about $40,000 before you hit something, or the same as 7 Shaheeds that basically will hit their target every time, unless they are shot down by some anti-aircraft guns or missiles. I wanted to give a little more reason here, justification for why you need 100 ordinary shells before you actually hit something. This is a picture of a field in Ukraine. It's actually taken from a satellite. And all these craters you see here are heavy artillery shells that have missed their target. They are landed in the field and not where they're supposed to hit. All the targets, they are hiding inside these tree lines here. There's a tree line here. And that's where all the tanks and armored fighting vehicles and all the soldiers have dug themselves down in some trenches and stuff, and you try to hit these tree lines here because that's where you know the enemy is located, and you can see there's an enormous amount of shells that just doesn't hit their target and don't do any damage to the enemy. That's why you need 100 before you can actually hit something. But let's move on. I have a lot of sources for what I just said here. So another reason why the Shahed is such a great build is that it uses a delta wing. And the delta wing is a brilliant design because it's more efficient than other kinds of aerodynamic designs. It's the most efficient you can construct. But it also has a problem. If you have a slow flying delta wing as this Shahed is, then you have an angle of attack when it goes through the wind that will give some turbulence, that will create air drag, and that will create inefficiencies. But you can, by putting these flaps on the wings, you can diminish this air drag a lot. That's just why they designed it like that. You could say, why don't we build every airplane as a delta wing when they're more efficient and you can get more range from it? It's because if you have a commercial airline, you'd like to have a large fuselage in the middle. So this would be the fuselage, and where you could put passengers or cargo into, and then some wings that sticks out from there. Whereas if you have this delta wing, well, you won't have this large fuselage. You just have one big wing, and it's more difficult to design a passenger or cargo plane if you use this design. Also, a delta wing is harder to control than a traditional airplane. A traditional airplane is self-stabilizing in the air. So if an engine stops working or there's a lot of turbulence in the weather, it still flies very stable, whereas this delta wing might actually crash. So that's why not all aircraft are built like that. But frankly, if you ask me, I think in the future a lot more airplanes, even commercial and cargo airplanes, will be built like delta wings, and also military planes, because this about controlling the airplane so that it's stable in all kind of weather. You can do that with computers. They can control the airplane so that it will be just as safe as any other. And then of course there's still this about how to get the passengers in. Well, build them bigger, build some really big airplanes, and then they can then you can stand up inside a delta wing. There's another problem. You won't have any windows because the whole wing can be full of passengers or cargo and also fuel. So there won't be any windows. Only on the edge here can you put some windows for people to look out of, and maybe people don't like that, but I don't think that would be a problem either. You could put some big screens in and then just fake a view out of the airplane with that. Anyway, let's keep on going here. Another reason why I think this is a great construction is they have simple, affordable controls. I do believe I have some pictures I show you here, and I do believe here you can see the engine is on the back, and here we have an engine that has been ripped off from a drone that was shot down in Ukraine. And I think it sits here on a gimbal, so you can actually, with a gimbal, you can also control in which direction this engine is blowing the air from this propeller that it rotates. So I think there is a gimbal control here. And then you can also see on this picture down here, you can see there are 4 flaps with an actuator, with 4 actuators here that control these flaps up and down. That's how you control it. So, and it's all cheap. A gimbal is cheap and these actuators are cheap. So it's a simple way to control it. So another reason that the Shahed drone here is great is that it has very affordable and also robust navigation. Of course, it needs to hit its target. How does it do it? Well, it uses a combination of satellite navigation that uses signals from, publicly available satellite navigation systems like the US, it's called GPS, and EU, there's Galileo, with the Russian GLONASS, and China is called Baidu. And all of these signals are publicly available. All these countries behind those networks also have military signals from the same networks that are even higher precision. And then it uses inertial navigation as well, and I'll talk a little about why that is smart. So if the satellite signal is jammed, the drone can still find its target using this inertial navigation that uses motion sensors, that is accelerometers, and also rotation sensors, that's gyroscopes, and a computer to calculate how its new position is given the last known satellite position and subsequent movement of the drone. These sensors are all measuring the movement of the drone, so if you know the position of the drone, these accelerators can basically be used to compute where the drone is 10 minutes later because it has registered all this information about the drone. And you might say that sounds like something extremely expensive, using these motion sensors and rotation sensors with gyroscopes and stuff. It's not expensive. Let me pick up a phone here, an iPhone. Every single smartphone has this sensors built in. When you take up your phone, a gyroscope registers that you have picked up your phone and your screen is ready to use, and the face scanner starts because of that. So we have all these sensors built into the phones, and phones cost less than even expensive smartphones is like $1,000 US. And if you only need these sensors, they are like $10 a piece. You only need the chip for this particular kind of sensor. So they are cheap. And also the GPS antenna, it's also a very cheap chip. It's like also a $10 thing if you buy them in large numbers. And then also some weapons may use, for more precision, they have a barometric altimeter that measures pressure in the air in order to calculate how high up it is. Because the higher up you go, the less the air pressure, and so there's this regularity. And then there are also some speed sensors. Anyway, we know that this Iranian Shahed drone uses just the GPS signal and also these inertial navigation. And here I come with some numbers that says that, if you don't jam it, if you cannot successfully jam it, then it will be at least able to hit its target with a precision of 4 meters, plus minus 4 meters, using a public available GPS signal. And if it has a military signal, then it will be like 30 centimeter. And then if you are successful at jamming it, say from 30 kilometers before it hits its target, so it's completely jammed from it reaches the target and 30 kilometers out. Then I pulled some numbers out of my behind here because I really couldn't find it on the internet. So it's just to give you an example of it. Don't trust these numbers. They could be different. Then precision perhaps goes down to 40 plus minus 40 meters if it can be jammed effectively 30 kilometers from target. I don't think military drones and missiles are easy to jam because this HIMARS missile that Ukraine has used, it has hit its targets every time exactly, and it also uses GPS. And Russia has definitely put up jammers around important installations that they don't want this HIMARS rocket to hit. So, and it still hits them. So I think actually there are ways to work around in a military weapon where you can come around this GPS jamming. I don't think GPS jamming is effective on military applications. You can easily jam, say, the GPS in a mobile phone or a car. But if you have a drone flying or a rocket flying, it could have some systems with it. And I'm just guessing, but it's highly likely that you can aim the antenna just to look for the GPS signals that comes in the direction of space and nothing else. And that means in order to jam it, you would have something that is in between the drone or the missile and space itself, where the signal comes from. There's a fourth improvement that I believe SpaceX could do if they were to build the Shahed drone, and that is to use military GPS signal to increase accuracy to 1 foot and also make it highly unlikely to be jammed. I'm not sure the Iranian version, as it was built in Iran, had these capabilities. Both the military, Iran doesn't have their own satellite GPS system, but now they are allied with Russia, and Russia has said, that was on the internet, I could find that Russia has improved the Iranian version with their own military-grade GPS, so it had better precision. But of course, SpaceX could do the same thing when they built the drone. And then a fifth improvement that I suggest here for SpaceX to do if they should build the drone is to make a variant of the Shahed drone that can also home in on radar and jamming signals. And if the signal is turned off, it will just hit a secondary target instead using GPS. That kind of logic you could build in for very little extra money in the warhead. It shouldn't cost that much. So let's go on. Another reason why the Shahed drone here is super great is that it can overwhelm any known missile air defenses by sheer number. It only costs $6,000 to produce each Shahed. So if you spend $6 billion, you can get 1 million of them. 1 million. That's a very large number. And even if you use the entire stock of NATO's anti-aircraft missile systems, you would only be able to shoot down about 50,000 Shahed drones. And it's even worse for Russia. They'll probably only have 1/3 of what NATO got in their stock. And I have some data that can back that claim up. It's this table over here. It shows the different kinds of missiles that Russia has been pounding Ukraine with, and their stocks of these missiles before the war started. And one of these missiles here is the primary anti-aircraft missile that Russia is using. That's this S-300. It can also be used as a ground-to-ground missile. That's why it's in this table here. But it's also the primary Russian anti-aircraft missile. They have only 8,000 of them. And then they have some S-400, probably have a few more thousand of those. And then they have some mid-range and short-range missiles. And yeah, who knows, maybe they have 20,000 of those short and mid-range. But that's what Russia has, all of it. So it can easily be overwhelmed if you build a lot of these Shaheds. And another thing about anti-aircraft missiles is that they cost way too much to be used on a $6,000 drone. Although they can easily shoot down that drone, it's not a problem for them. It's just too much money to spend. For instance, a short-range Stinger missile costs $120,000, and a mid-range Nassam missile, that's like 20-30 kilometers range, is $1.2 million. And then the creme de la creme of NATO's air defenses is the Patriot, the US-made Patriot missiles. They cost $3 million, an enormous amount of money. But I also think they can shoot down ballistic missiles that come in really fast from space, and that requires a special missile to shoot that kind of things down. So obviously, if you need to spend at least 20 times more money to shoot down one Shahed missile, or even as in the case of the Patriot missile, you need to spend 500 times more to shoot down just one Shahed, that's not sustainable at all. Plus, you don't have the numbers. Okay, there's also a reason why the Shahed drone is not so great, and that is its slow speed and strong radar signature. So it's easy to target for a missile or an anti-aircraft gun. But we have ruled out the missiles. They're too expensive, so we can't use them really. But we can use anti-aircraft guns. They're far cheaper method to shoot down a Shahed. They'll still cost several thousand $dollars worth of ammunition per drone kill, but that's manageable. And there are two kinds of anti-aircraft guns. One is just a really fast machine gun that's possible to aim precise at the drones when they are within, say, 3 kilometers distance. And then they shoot a burst of, say, 100 bullets towards the target in the hope that some of them will hit the drone critically to down it. And the other kind of anti-aircraft gun is one that uses fewer rounds that are shot at the target. But these rounds have proximity fuses, and they can explode when they are, say, 10-15 meters near the target. Then they explode and put out a lot of fragments that will hit the drone and down it. But the Shahed here is able to fly at 4,000 meters altitude, and at that altitude most anti-aircraft guns cannot reach it. Most anti-aircraft guns has a range of about 3 kilometers. This one I'll show here in this picture is the German Gepard. That has actually a range of 3.5 kilometers. And it has exploding ammunition. I don't think it uses proximity fuses, but it uses another system of basically timing when the grenade there should explode. And that's programmed just before it's shot by the radar system of this Gepard. That's how I think it works. And it only has 320 rounds. That's probably enough for 10 drone kills if it's lucky. We should consider how much reaction time does an anti-aircraft gun have before this Shahed drone could hit them if it targets the anti-aircraft guns. And at 3 kilometers firing range, you have only about 1 minute for this anti-aircraft gun to destroy the drones, because 3 kilometers is what you will fly if you fly at the maximum speed of this drone at 185 kilometers per hour. So one attack strategy can simply be to overwhelm an anti-aircraft gun by flying enough Shahed drones towards it so that it cannot shoot all of them down. One of them at least will get to it. And it will still be an important kill for the Shahed drone to take out an anti-aircraft gun, because an anti-aircraft gun can cost $10 million. I also have an idea for how SpaceX could further improve a Shahed drone. They can make the attack angle of the Shahed programmable. Instead of flying in a cloud of drones towards the anti-aircraft gun, it will come in from all sides simultaneously, so that exploding rounds from an anti-aircraft gun cannot take out several drones at a time, but at most one drone at a time. And also the tower has to turn around. You can see this tower will have to turn around. If they come in from all sides 360 degrees, it'll be much harder to shoot it down by an anti-aircraft gun. So that would be one improvement that SpaceX could definitely make. Now, before we leave this slide, I should show you how it works, this anti-aircraft gun in action, because I have a little video here. Let's see it. Here we have the Gepard. The radar is turning, and here it shoots at an airplane that's going up from an airport, and that's how that is. There is actually a third way to shoot these Shahed drone downs apart from missiles and anti-aircraft guns, and that is to use helicopters or airplanes that have a machine gun mounted to fly after them and then shoot them down. Again, because they fly so slow, they can be shot down by a helicopter or an airplane that flies a lot faster. So they can engage the Shahed much earlier than an anti-aircraft gun that only can engage in the last final 3 kilometers. But these airplanes and helicopters can engage the Shaheds over the entire flight route. So it flies 600 kilometers. In principle, it has 3 hours to go up there and engage and shoot it down. But still, there are one problem with that. There are a couple of problems. Normally helicopters like this Apache helicopter, that's a flagship attack helicopter in NATO, and then also F-35 here, that's also the flagship fighter in NATO. They only have about 220 rounds of 25 millimeter standard ammunition, but they fire them really fast, and it's probably enough to shoot down 2 or 3 Shahed drones, and then they're out of ammunition. They were not really designed to deal with millions of Shahed drones. They were only designed to shoot down other helicopters or airplanes, but not drones. So again, NATO needs to prepare for future wars by adapting our helicopters and airplanes so they are much better suited to shoot down drones. They need much bigger magazines here so they can shoot down more. And then there's a problem in Ukraine that has tried to use their helicopters and airplanes to shoot the Shahed down. The problem is, in Ukraine, stuff they have to work with is pretty old. They can only shoot the Shaheds down if they attack in daylight, because the pilots require daylight to actually see and aim for these Shahed drones. But the Russians, they're not attacking with daylight with these Shahed drones. They attack at night, and at night they can't see them. Of course, if Ukraine had NATO standard airplanes and helicopters, they would have equipment that could see the Shahed drones also at night and then have a fair chance to shoot them down. But I found a quote here from a Ukraine military newspaper that reported that each of the types of the MiG-29s, that's a Russian airplane they have in Ukraine army, onboard weapons has its own shortcomings in certain conditions of hunting for Shaheds. For example, the onboard 30mm cannon is effectively only if the interception takes place during the day and the Shahed is in line of sight. So they simply can't aim on it during night because they can't see it. So that's it. Then I have a lot of sources as usual, and you can download it. And that brings us to chapter 4. So the 4th chapter here is why SpaceX is uniquely positioned to make the Shahed drone even more revolutionary. And I think I'll start by repeating the 6 improvements that I've stated in the previous slides, because it's good to refresh our memory with that. So the first one was to make a catapult launcher powered by an electric motor that winds up a pull cable for the drone. So same as in a modern aircraft carrier. And make that catapult system fit a standard 40-foot container to improve logistics on the battlefield. And the second improvement was that it should also be able to launch using a landing gear that's also mounted at the same place that this launch rocket can also be placed. And there can be two ways to use this landing gear. Either it's just dropped off the landing gear immediately after takeoff, because then the range of the Shahed will be longer. It'll be the full 600 kilometers. Or if you suspect that the mission might be aborted or something during the flight, then it should be able to return home and land using that landing gear and then be refueled and used for another time. That would require communication with the drone, and I'll talk about that shortly. Otherwise, you couldn't abort a mission. A third improvement could be, that's the most important one, to mass produce a Shahed using a metal frame and body and make it as we do in a automac factory, and then bring the price down to $6,000. That's very important, because that means you can mass deploy them by the tens and hundreds of thousands and even millions for a very large army. The fourth improvement I suggested was to use military GPS signals to increase accuracy to 30 centimeter or about 1 foot. And the fifth improvement was to make a variant that can also home in on radar and jamming signals. And if these signals are turned off, then the drone should automatically pick a secondary target instead, using that GPS. The sixth improvement I suggested was to make the attack angle of the Shahed programmable in order to make anti-aircraft guns the least effective against the Shahed. Specifically, you could attack simultaneously from all sides, or 360 degrees. It would make it much more difficult for an anti-aircraft gun to actually shoot it down. Now, a new improvement I'll suggest right now is to decrease the wingspan of the Shahed to 2 meter and 38 centimeters, so it can fit inside a standard 2.43 meter width of a standard shipping container. And then 12 Shaheds could actually fit into such a 40 feet standard shipping container. That will again make battlefield logistic a lot simpler if you can use standard containers and semis to haul these Shaheds around where you need them. And the Iranian Shahed, funny enough, is 2.5 meters, so it cannot fit a standard shipping container. That's a huge mistake they did there. But they have this other system where they launch with a rocket from a truck. But then they need a truck for every 5. There were 5 Shaheds in every truck, and they need a truck for every 5 Shahed they have. This other system here, you can just bring up to 12 of these Shaheds with each container, and you can place these containers all over the country and near a launcher, and then you can start launching. It's a much better system. But there are many other things that SpaceX can do. The 8th improvement that SpaceX could do is that they could use Starlink to communicate with Shahed drone in flight using their new Starlink Block 2 satellites that enable low-speed internet connections using ordinary 5G radios that may add as little as $20 to the cost of the Shahed. It's also worth noting that Russia has been trying to jam and hack Starlink satellites in Ukraine, but they haven't succeeded. So one thing that I expect to be made on such a Shahed drone that can communicate with the Starlink system is that these 5G radios could be made directional, so they only receive radio signals directly from space, and they also only send out their own radio signals directly up in space, so that a jammer needs to be located between the drone and space in order to be effective. And of course, Russia don't have any jamming systems, unless of course they launch a jamming satellite system and that could do the jamming from space. But they don't have that. You know, it would be a massively game-changing thing for a Shahed to be able to communicate in real time safely with the internet or via this Starlink system. One reason is that Shahed would be able to acquire a new target or new flight route if intelligence discover that a higher value target is available, or discover that enemy anti-aircrafts are active on the flight route that the Shahed has been programmed to follow. So just get another flight route in flight or another target to hit. Also, with live intelligence, Shahed potentially could be able to hit moving targets like tanks, armored fighting vehicles, and trucks while they move, if you can get the information timely enough with new GPS coordinates where this tank is moving. Also revolutionary. And Shahed could also be ordered to abort primary target and go for secondary target instead if, say, intelligence discover that the target is no longer valuable or there are many civilians at risk near the target that you don't want to kill at the same time. SpaceX should also make a surveillance Shahed. That would be improvement number 9. They could make a version of the Shahed that replaces a 45 kilo warhead with a 35 kilo warhead plus a 10 kilo package for optical and thermal cameras and batteries for surveillance. The Starlink Generation 2 satellites that SpaceX currently are launching for their Starlink constellation, they are using 1.4 gigahertz and 5 gigahertz radio bands. My channel that where I have it from, they say they use megahertz, but that's not true. And they are capable of 3 megabytes per second to 7.2 megabytes per second peak upload Earth to space. And they're also capable of 4.4 megabytes per second and 18.3 megabytes per second for the downlink, that's space to Earth. Especially the uplink is important because if it's an intelligence that gather information, then you want that uplink to be as powerful as possible. But 3 to 7 megabits per second is actually quite good. But it has to be understood that this is a capacity that is per hexagon cell that covers 379 square kilometers. And here we have a map of it, how Earth will be kind of divided into these hexagon cells. And then there is this capacity for each of these cells. Of course, if you send up more satellites, there will be twice that capacity for the same cell. But that will require 2 satellites over this area at the same time. And that Starlink connection here is fast enough to transfer high resolution still pictures and also low resolution live video. Live video in high resolution require a little more than 3 to 7 megabits per second. But you can definitely transfer some very high resolution still pictures and some low resolution live video. So surveillance Shahed will cost more than those $6,000 that I said the quick and dirty Shahed would cost to make, because this warhead would add cost. In mass production, I don't expect it will add more than $1,500 more to add some cameras, and the thermal camera will probably be the most expensive thing. Ordinary cameras and a little zoom functionality doesn't cost much, and the batteries will not cost much at all. So the total price will be $7,500 for this surveillance capable Shahed, but it will still be able to strike because it still has a 35 kilo warhead with explosives. So it can do both strike and surveillance. And then we should also note that if you are flying this Shahed in a reusable mode, then of course it will have a landing gear so it can return home and be refueled, and that landing gear will probably also cost about $500. So total price will be $8,000 for a fully reusable surveillance and attack drone. It's still a super low price for a weapon that now has enormous capability. Also, it should be noted that if this Shahed flies with a landing gear, its total range will likely drop from, I'd say, 600 kilometers to 500 kilometers, and then its operational range, if returning to takeoff site, will be 250 kilometers. It's still a lot. It's not bad. Remember, the HIMARS missiles were only 70 kilometers, the range for these missiles, and they costed a lot more. Now, SpaceX can also do another improvement that will be enormously important. That's number 10 improvement here that I'll suggest. And that is that this surveillance Shahed should have the ability to navigate using uploaded visual maps of the landscape along its flight route, so it can reach and hit the target in case the GPS system is effectively jammed, which we don't think it can be. but it could be nuked. You know, the Russians could decide to blow up all satellites in space. That will, of course, blow up their own satellites as well, and also China's satellites and India's satellites. So they will really be very unpopular in the world if they do that. But they could bring the whole satellite system down and basically also destroy Starlink's ability to communicate with the Shahed drones. But if they have this ability to navigate by maps, then they are still useful. These drones are not lost. They can still be sent out using maps that were already made, or maps that are gathered by Shahed itself. They can be programmed to fly along a route and update maps, and then they can use these maps to target the enemy and hit targets still. So that's a pretty good thing. The only drawback here is that in clouded weather, the Shahed would have to fly below the clouds to see the landscape, and then it risks being targeted by anti-aircraft guns because, well, clouds, I don't know how high they are, 2-3 kilometers. Have to go down below those, and then anti-aircraft guns can hit it. Okay. Another thing SpaceX could do is to build a constellation of spy satellites. Again, SpaceX is uniquely positioned to build a spy satellite network providing high-quality intelligence on a massive global scale for target acquisition, flight route planning, and target evaluation for this Shahed drone. It's one thing to have a good weapon, but without good intelligence about where to deploy this weapon, where to hit the enemy, and also evaluating how successful your hits are on your enemy, it's far less useful. So that's why a satellite network where you can watch the Earth in detail, getting this information, is super important for making this weapon more effective. So why is SpaceX better positioned than its competition to make such a constellation of spy satellites? Well, SpaceX Falcon 9 rocket here is able to launch mass to orbit at $2,700 per kilo. That's what they charge currently. And all their competitors are charging between $7,000 and $15,000 per kilo for same kind of launches. So they are way ahead of their competition here to launch stuff into space. Also, what's even more impressive is that SpaceX is far ahead with their development of their next rocket, which is called Starship. They have been doing that for 7 years now, developing, and now it's finally close to having its maiden flight. Very excitingly, next month it will have its maiden flight if everything goes well, and it could be fully operational for cargo launches by the end of this year. Why is that important? Because it will be the first fully reusable Starship on the planet. That's never been done before. And potentially, Elon Musk is saying that the operational goal for that Starship is, when it's fully optimized, that it can get to as low as $10 per kilo to orbit. You know, $10 per kilo to orbit, down from their current $2,700 per kilo. That would just be a revolution beyond imagination. But it is possible. The fuel to fuel the Starship is less than $1 million, and this $10 per kilo is derived from a launch cost of $1 million for fuel and also capital cost of Starship. Then it will be $10 per kilo because it can launch 100 ton to low Earth orbit. Even if it's 10 times higher than that, and that's definitely doable, that would be $10 million per launch. Currently, the Falcon 9 is cost about $50 million, and that has this price there of $22,700 per kilo. So $10 million for Starship launch when fuel is less than $1 million, and it's fully and quickly reusable. That's definitely doable. Also, SpaceX has demonstrated ability to mass produce satellites. It's not only launching the satellites, it's also producing the satellites. SpaceX has made over 3,000 Starlink satellites right now and launched them, and they have gotten the price down to, they're a little secretive about it, but it's about $250,000 to $500,000 per satellite. That's the cost of it. That's very low. when we compare with the price of other satellites are up there. I Googled it quickly, and I saw that a typical spy satellite will cost you $100 million US. A weather satellite is almost $300 million. And a non-SpaceX communication satellite is like also a $300 million thing. Now, these satellites are normally quite a lot more heavy. They're like 3 or 4 tons, whereas these satellites SpaceX has built are like 300 or 400 kilo. So they are smaller, but still there's a long way from their $500,000 to US dollars to $300 million US dollar. And it's all about Musk's first principle thinking. Really, if you can mass produce things in large enough numbers, then all that matters is really the cost of the raw materials. You will approach that cost. Raw materials don't cost more than a few $100s to a few $1,000s per ton. And that's why it's possible for SpaceX to do satellites like this sub $1 million US per satellite. And it's only SpaceX who has done it. There are really nobody else who have done mass production at that scale. And we know that because found out some data that on January 2022, Earth had about less than 5,000 active satellites in orbit. More than half of those were SpaceX Starlink satellites. So really nobody have achieved mass production of satellites like SpaceX has. It really is the company in the world that can make a bigger and cheaper constellation of satellites that could spy on the Earth. And they should do it in order also to enhance the capabilities of their Shahed weapon. Now, I have also investigated what kind of spy satellites that it would make most sense for SpaceX to focus on building. And I have concluded that it has to be synthetic aperture radar spy satellites for several reasons. There are 2 kinds of spy satellites that are kind of the main spy satellites, and one is optical spy satellites that uses ordinary cameras and zoom lenses, just like any camera you would have here on Earth, and uses the wavelengths of our own eyes, the visible light. And that's one way to make images of the Earth. There's another way, that is to use these synthetic aperture radar spy satellites, and they use radar instead of optical light. And that has some advantages, and one of the advantages is that radar can see in all kinds of weather. They penetrate clouds, so they can generate images, high-resolution images of Earth, even in bad weather, with cloudy weather, which is not possible with optical satellites. They'll just see a lot of clouds and nothing else. They can't penetrate it. Moreover, they can also see through vegetation. And normally for military use, you will use a forest or some trees to hide your weapons, to hide your people. So tanks and armored fighting vehicles and stuff and trucks will be hidden under some trees. But these radar satellites see right through that and only make an image of the ground and whatever vehicles and stuff that is on the ground. And so they're much more useful for military purposes. And they can also see at night. It doesn't matter that there's no light on the Earth, because radar satellites send out their own light from the satellite. It beams down a radar signal, and then it listens for the return of that light to reach back on the satellite. Whereas optical satellites, they use the light generated by the sun. But when it's dark and it's night, then there's no return light from the sun, and then they can't really see anything but a black Earth. They could of course see city lights and stuff, but that's not that interesting. For obvious military reasons, synthetic aperture radar spy satellites are far more interesting than optical satellites. You can still get better, higher resolution with optical satellites than you can today with synthetic aperture radar, but it might be a matter of time before you can actually get the resolution of these radar satellites up to a level that is comparable with optical satellites. But we'll see later in my presentation. I have some pictures where I'll show you both satellites images from optical satellites and also from these radar satellites, how good they are. And there is another reason why SpaceX should first, at least they might do optical spy satellites at a later point in time, but not at first, I think, because the next rocket from SpaceX is their Starship, and that Starship is designed with a satellite dispenser system. We can see Starship down here, and there is a satellite dispenser system that throws out the satellites through a small opening here, and then they are stacked inside and they are just moved down and then pushed out. That means they have to be like a flat envelope shape, and you cannot build an optical satellite in that envelope shape. It needs to have some optics that it needs to be in a box-shaped satellite. So that Starship cannot dispense these optical satellites. They have to be flat. But a synthetic aperture radar satellite, you can build that flat. All you need to have is the solar panels that provide the energy. They fold out and they are flat. And you also need to have this radar antenna that is also something that can be folded out and that is flat. That's the one that sends out the radar signal, also the one that receives the radar signal. And then there's something else I discovered. I don't know if I'm right in that or wrong, but I actually believe that there's a possibility that the same kind of antenna that you use for synthetic aperture radar would be the same kind of antenna you use for communication at Starlink. Because look at the wavelength. The wavelengths of Starlink's Generation 2 phone communication ability has a wavelength of 1.5 gigahertz to 5 gigahertz. And that's a wavelength from 20 centimeter to 6 centimeter. But the wavelengths for radar satellite is reported to be from 10 centimeter to 1 centimeter. So it's kind of overlapping. And that make me conclude that you can actually use the same antenna for communicating with wireless radio in phones that Starlink can do. And it's the same thing you would use for generating these radar images. There's an observation I found very interesting, because that means SpaceX already has the expertise to build these synthetic aperture radar spy satellites. It's not something completely unknown to them. And who knows, maybe they can already do it. They just kept it secret to prevent the Russians and Chinese from knowing what they can do and what they're doing with these satellites. It's just a discovery I had made here. Be funny if it's true. And something else super interesting is that there's something you need to know about these synthetic aperture radar spy satellites. Why are they called synthetic? It's because the aperture is actually much bigger than the length of this antenna that can pick up the signal. The problem is the wavelength is quite big. It's 10 to 1 centimeter compared, and that's 100,000 times less than that of visible light. And because of that, you would actually have to, in order to make a high resolution image, you would have to have an enormous antenna that would have to be thousands of kilometers long in order to get high resolution pictures. And obviously here you can see it's not 1,000 kilometers long, it's just like, I don't know, 10 meters or so. So how do you get it to become thousands of kilometers long in order to get high resolution images out of this satellite? Well, you do it synthetically, and you utilize the trick that the satellite is in orbit. So you can basically send out the signal and receive the signal along all the orbit of this satellite while you're looking at the same thing. And that's how they do it. That's pretty brilliant. And by the way, it is called interferometry. So I'll just read up this. So these radar satellites, they use interferometry to combine radar signals gathered from several locations in space as they move around Earth to magnify the resolution of the radar signal reflected from Earth. That's how it's done. And it's the same technique that was used by humans here to make images of black holes out in the universe for the first time. That's very recently been done. They used radio telescopes and the rotation of Earth to make a synthetic aperture, so they could get a much bigger radio telescope, actually the size of the Earth, synthetically, by using individual radio telescope on Earth that were much smaller and had much smaller aperture. So it's the same trick. It's pretty hard to make these synthetic aperture radar spy satellite function. And they require a lot of data processing in a data center back on Earth before the images are made in a form that can be comprehended by human brains and looks like an optical image where you can see tanks and armored fighting vehicles and airplanes and ships. They need a lot of data processing, and that's one of the reasons SpaceX should pick this up, because Elon Musk is also the CEO of Tesla, so he knows a lot about data processing. They have one of the biggest data centers at Tesla that are processing all the data from their self-driving cars, and they use AI and stuff on it. So it's right in his ball game to be knowledgeable about this. Data centers and stuff will be needed to support all the data processing from a huge constellation of thousands of these synthetic aperture radar satellites that SpaceX could launch. Now, I also think that SpaceX should develop the antidote for this 200 kilo Shahed drone. We need better weapons to counter this threat. And it is going to be a threat because it's obvious now that each year and with each new war, drones become ever more important in numbers and abilities. This trend will of course accelerate when the first large factories that are designed like automobile factories are beginning to spit out these Shahed-like drones in very large numbers. And we know already that Russia is in full swing preparing mass production of Shahed for use against the Ukraine. And it's a huge problem that no one currently have developed a great drone killer for slow-moving, inexpensive drones. We need to do that. And the best current anti-drone weapons are probably these anti-aircraft guns with bullets and explosive rounds. And they can be overwhelmed. Just send enough Shaheds against them from all attack angles, and they can only react for 3 kilometers and only 60 seconds. So you can overwhelm them, and then you can destroy an anti-aircraft gun that costs $10 million with 10 of these Shahed drones that cost $60,000 if you've used 10 of them. So what really would be the solution, the antidote for this drone, is to make a much smaller and faster Shahed drone to kill other drones, but also killing infantry and for intelligence gathering. And SpaceX should make that drone as well. Here in this presentation we just call it SpaceX Shahed Mini for infantry and drone killing, and should have a 1 kilo warhead and a short range and also be able to do surveillance. And the reason there's a triple role here for killing other drones and hunting infantry and also intelligence reporting, that's because then it's much more versatile and it will be ordered in much larger numbers by armies around the world. And that makes the cost go down. More you produce of them, the less they will cost to make. So let's take a look at what could realistically be the properties of such a mini Shahed drone from SpaceX. It should weigh about 14 kilo instead of those 200 kilo for the ordinary Shahed. With 14 kilo it can be handled by humans, and it should also keep its delta wing design with a propeller at the back and then 4 control flaps. Now there is an RC drone here also with this propeller at back, and it only has 2 control flaps. But I think 4 flaps is better, because if it's shot at with an anti-aircraft gun and one bullet hit one of these control flaps, then it will crash. But if it has 2, it should be constructed so that it can still maneuver with one of its control flaps being destroyed by a bullet or some shrapnel. Also, how should it launch? Well, it should launch from a catapult, or it could be handheld with a pull cable, or you could have a soldier sit in a motorbike basically running through a road until it gets to the speed where it can fly itself, and then he just releases it. That could be one way to do it. But I actually have a pretty good video about it, how it could be launched, and this is for this one down here. So let's click that. So here we have a Shahed style drone, delta wing. It has a propeller here on the back. It's also electric, and it's launched here from this catapult. That's brilliant. And it's just mechanical, this catapult. It doesn't, maybe there was an electric motor that winds up a cable there. I don't know. Let's watch it again. See if we can see how it's done. But it could also be just a wire or that is mechanically strengthened that pulls it off. Anyway, it looks like it's very affordable. You could probably make a catapult like that for $1,000. It would be preferable if it doesn't use electricity, if it's just dirt simple, and you just pull it up by turning a wheel around, and then that's how you strengthen some kind of spring or something that has the force to launch the drone. But that's how it could be done. You could build thousands of them and have drones ready for takeoff, sitting on these catapults. Okay, landing, it should not have a landing gear. One way you could land them and retrieve them is simply by crash landing in a large elastic net. So you have a big net where the drone could fly down towards that net and then basically make a maneuver where it goes up, straight up, turns off the motor, and then simply drops back and falls into this net. Which will give it a soft landing instead of just landing on the ground, risking that something will break during the landing. That's how I would do it. Just keep it simple. And then a warhead, it should have a 1 kilo warhead with a directional schnabel. That would be good for killing infantry, but it would also be good for killing other drones, that it sprays out a cloud of bullets in front of it. And with 1 kilo, that's a lot of bullets. You could put your way 100 bullets, like in a little cloud in front of you that could kill infantry or other drones. But it wouldn't hurt a tank or an armored fighting vehicle. For that, you should use the 200 kilo Shahed. And also, I should mention here, it should have a 10-meter radar proximity fuse. So that's needed if you want to kill other drones. So when it's in a proximity of 10 meters from another flying object, that warhead detonates. The same thing when you are approaching the earth and try to kill some infantry in a trench. When it's 10 meters over that trench, that warhead detonates and spray a cloud of bullets over trench with infantry inside it. There should also be this spy module in addition to the warhead. That could be a 2 kilo thing with an optical and thermal camera and also active radar homing. It needs this active radar homing in order to be able to home in on flying objects in the sky, or it will not be able to kill other drones. And that will take some weight. I'll come to it in a bit how that radar could be designed so it's not a big radar. Speed, it should be faster, of course, than the Shahed, the 200 kilo Shahed. So 350 kilometers per hour, that's probably what it should be designed to do. And actually, this movie up here shows this RC drone, which is delta wing and it's also electric. It has a speed of 210 miles per hour and 337 kilometers per hour also. So let's take a look at it. It's launched. Also, the launch system is a pull cable basically that launches it. That's another way to launch it. And look, it doesn't say anything. It's almost soundless. Okay, here you could hear it a little more. But I think that's a pretty good video of how it could be done. So range and duration, I think something like 40 kilometers flight range, and flight time would be 45 minutes. And I think that would be good enough for drone and infantry hunting. Then flight height should be same as a heavy Shahed, from 10 to 4,000 meters. And propulsion, that should be an electric propeller with rechargeable battery and fast charge to 80% in 10 minutes. In war situations, speed is sometimes important. So if you have recovered a drone, it's important that you can recharge it fast so you can send it out again. Could be a situation where you actually need it to be sent out immediately or as fast as possible. And then fast charge would be an important feature for this drone to have. And why should it be electric and not gasoline? Well, electric is certainly more quiet. These Shahed drones, the 200 kilo, they are quite noisy, and they can be heard from far away and kind of warn infantry to get into a bunk or an armored infantry fighting vehicle when they can hear that something is coming. To hunt infantry, it would actually be better with an electric powered drone that is soundless. It should be able to surprise people, and it will be able to surprise if it's soundless. And it's also less complicated to maintain in the battlefield if there's no gasoline involved. With a gasoline engine, there could be cold weather issues and stuff like that that's not present when you have electric drones. Then there are some control modes. I think it should be that should be possible. There should be a DJI control mode. We all know DJI, that's the biggest drone manufacturing company in the world. And there should be a remote controller like a DJI controller where an operator could send out the drone and have a video link to this thermal and optimal camera on the drone with up to 10 kilometers radius. These 10 kilometers radius from operators, that's the same as any normal DJI drone. It could probably be larger. Maybe it could be doubled if you had a more powerful transmitter and receiver from the controller. I think it could easily be doubled. So that's a possibility. But I just say 10 kilometers because I know that's possible with DJI drones. And then there should also be another control mode that's a Starlink control mode for drone killings. And how does that function? Well, there could be an independent radar station that detects incoming enemy drones. And then a control center that gets those radar signals will calculate the trajectory of these enemy drones and call up Shahed mini drone operators in that trajectory to launch the Shahed mini drones that are sent GPS coordinate via this 5G link to Starlink to get within 1 kilometers of the enemy drone, from which after which the drone is armed and use an active radar homing to get within 10 meters of the enemy drone before it explodes. And that's a pretty smart system. It can be operated fully automatically. This control center could automatically launch these drones that sits in their catapults. So it doesn't even need to call an operator. It can all be fully automated. And then it basically flies within 1 kilometer of this enemy drone, and then this active homing radar system takes over. The closer you can get it to the enemy drone, the smaller the radar in this Shahed drone will have to be, and the cheaper it is to manufacture. So that's why I think it should just use GPS signals to get within that distance before the warhead is activated, and it does its own homing on the enemy drone. But say the Russians are nuking all the satellites in space and there's no Starlink that can be used to send GPS coordinates to get the drone within the 1 kilometer range of the drone. In that case, there should be a DJI control mode for drone killing. So same method as before, there's this radar station that picks up where the enemy drone is, and then a human operator should be called up and say, now you launch your mini Shahed drone and you should fly it in that direction. You could be given those GPS coordinate and you fly to that coordinate, and then he just waits for new coordinates. If more coordinates are needed to get, say, the Shahed drone of the enemy Shahed drone is changing course or something, then a new coordinate must be reported to the operator, and then he just steer the drone to that new coordinate. And then when it's within 1 kilometer, well, the drone will take over and do its own homing and shoot it down. So it can be used without support from this Starlink system, because it could be nuked and be completely down. So that's how I think this should be done. Then I have a lot of sources as usual, and then we get to chapter 5. So this chapter is about target acquisition and evaluation. How much can you see from space? Let's start by looking at some satellite images from space. This first picture here is showing you different resolutions from an optical spy satellite and also a commercial spy satellite. It's not a military grade. And here, this first image is from high up, and it's 375 meters resolution. Each pixel is 375 meters from each other. Next picture is at 15 meters resolution. Here you can see some roads and stuff, but it's only when you get to 0.3 meters resolution or 30 centimeter resolution that you can actually clearly see houses and cars and roads and trees. And maybe I should also say that this 30 centimeter resolution, I believe in the US there's a law against publishing images that are even higher resolution than that, I guess for privacy reasons. So obviously it's possible to do better than this, but this is what I can find on the internet that's publicly available. And here we have some other pictures, also optical spy satellites with a ship, and you can see there's a corn is being loaded into this ship, that it flows down here and fills up this ship. And what else can we see? We can clearly see the containers shipping containers here. Let's see another one. This is from Ukraine. It shows tanks, self-propelled artillery and armored vehicles that are stationed at Opuk training area in Kreminna, Ukraine, as seen in this Worldview free image from April 15, 2021. So it's obviously you can clearly see the individual tanks and trucks. Here we have some trucks. Over here we have armored fighting vehicles. Here we have some howitzers, and you would be able to get a GPS coordinate on each of those and then send a Shahed drone. Well, there are lots of targets here, so you send hundreds of Shahed drones to destroy each and every one of those. It's pretty great. And here the same thing, but just off an airbase where you can also clearly see the airplanes. And I do believe this is all publicly available, so it's 30 millimeter. It could also be AI enhanced. It's really good images. Russian Su-34 aircraft, and it's an airbase in Russia. This picture here is taken from Kabul airport in August 23, 2021, when they were evacuating Afghan people and US military evacuating themselves out of Kabul airport. And here we can see the people lined up. I think each if it's 30 centimeter, I think it is, you can actually see individual people here, but of course you cannot recognize faces or anything in this. But it's quite easy to see what's happening, and it's clearly good for military use. Now, this is the first synthetic aperture radar that I was talking about from space, and it's supposed to be 25 centimeter. I'm not sure about that. It looks like it's far worse, but that's what it says at the internet site where I found it. But this is done with radar. That means the images look exactly the same, whether it's totally clouded and rainy, whether it's day or night, because it's a radar signal. You can definitely see the ships here. That's two large ships that are docked for unloading or offloading, and some ships here are sailing in the harbor. And then we have an area here, to me it looks like a parking area for semi-trucks with shipping containers. And here, over here, these blocks we see here is probably just shipping containers that are stacked on top of each other. There must be a way to zoom further in, because I don't think it doesn't look like 25 centimeter to me. Here, this is from higher above, and it's just to show you that it's the same harbor. It's Rotterdam in Holland, and there are some storage tanks that I want you to take note of over here. And the next picture shows a zoom in of these storage tanks, how they look. Here you can actually see the pipelines connecting these storage tanks. You couldn't see that on this. These pipelines were not visible here. So that's how this radar looks. And as you can see, this radar, there's no color in it, of course. It's radar, it's not a color picture. So it will be some kind of, it's a lot of data that is incomprehensible for humans that are then processed in a data center to generate these images that we can actually understand. But you could do so much more with these data, and I'm pretty sure that SpaceX could do a much better job in getting the resolution way up. Also, this is done by a company. It's a Finnish company. It's not that big. A company is called IK. They're producing these radar satellites that are very small, actually, just a few hundred kilo. So they can produce many of them and can afford to get many of them up in space. SpaceX could do some that were significantly larger, and therefore also can take better resolution pictures. And they can still mass deploy them by the thousands. So I think SpaceX should do this. And here is a video actually of this radar, synthetic aperture radar, because they can also do video. So let's take a look at this video, run it now. This is an open pit mine where you can see excavators and huge trucks driving here. And up here you can see trucks that are coming up with ore. Let's take a look at it again. Take a look at this. Here we see the trucks are moving up. These are high enough resolution to target these trucks with a Shahed drone for sure. And that's on a video. Of course, these are very big trucks. They are big trucks. Tanks will be smaller than these trucks. These are probably trucks that can carry hundreds of tons of mining ore on their cargo bay. Now here we back to some optical space pictures with the resolution over on the left side here for 30 centimeter resolution, and that is a raw 30 centimeter resolution. Now over on this side, it has been improved the image, not by having a higher resolution, but by using AI to make an image as if it was taken with a 15 centimeter resolution. So that's quite impressive that you can clean up the picture and make it look a lot more high resolution this way. And that's just shown one example of what you can do with AI processing of images. Here's another example of what you can do with AI to improve image quality. Here's a high resolution black and white image. And then at the same areas photographed, as it called that, with a low resolution color image. And then you use AI to superimpose these colors on this high resolution black and white picture in order to create a high resolution color image. That's much easier on the eye for humans. And it's a smart idea, because if you just took a color image in this resolution, it would use up a lot more data for your satellite and communication links than if you just do it in black and white and in high resolution and then take a low resolution color image. That's a smart way to save data and still get the same intelligence out of it. This is an example of how Apple from our iPhones are using also AI to improve image quality. First, your camera in any smartphone, Android are doing the same thing. First, they take a lot of pictures. You can't hold your camera completely still. So that will be pictures that are taken shortly after each other, but they'll be slightly misaligned. So the compute here align the pictures, and then it does some merging of them that will increase the light and contrast in the picture. And then it again uses AI to enhance the colors so they look better in the picture. That's how AI can be used to do image quality improvements. But AI can also be used for other stuff, such as image comprehension. Once you have improved the image and you have a great image, then you can use AI to also annotate all the pictures and look for instance, in this example, AI figures out, okay, this is a highway. Here we have some farm group fields for farmers. Over here we have some industrial areas. Here we have a river running through. And here we have a residential area. All that can be done automatically. What you should imagine here for military purposes is that an AI can figure out where are the tanks, where are the airplanes, where are the ships, where are the armored fighting vehicles, and so forth, where are the troops. And it's important if you have thousands of spy satellites that can basically update a high-resolution picture of the Earth every, say, a few minutes, then that will be so much data that no human, even if you have millions of humans looking at it, they won't be able to find what they need to find. So you let data centers and AI look through all this and find all the military targets. And then when that's done, then you can have some humans look at it to get further information out of it, because we still have some tricks in our human brains that AI can still not do. It won't be long, then AI can do everything. Improvement number 13, SpaceX should also do the satellite image data processing and also image analysis for the image data gathered by the constellation here of spy satellites. So basically we have this process where we have some satellite image over in this figure here, you can see we have some satellite image data acquisition, and that's all the spy satellites that are collecting that. They send it down to a data center on Earth, and that then does a lot of data processing, actually make the pictures and clean them up. And then we use some satellite image analysis that could be done by AI for most part of it. And then finally, it's ready for satellite image usage or applications like in the target acquisition in a Shahed drone or target destruction evaluation afterwards. The target has been destroyed, and then you want to know how much it has been destroyed, whether you should send another drone. And that could be here, humans still have a role to play. And this synthetic aperture radar system that I suggest SpaceX should focus on, at least initially, it has this advantage, of course, of seeing at day and night, and also through covers of camouflage or trees that tanks and so forth has been placed under. But they require a lot of image processing, and also a lot more image processing than optical images. And that means these big data centers are needed, and also world-leading AI development. And both of these things are something that Elon Musk, the owner of SpaceX, has a lot of experience with, because he's also working on Tesla, and they have a big data center and also one of the world-leading AI development teams there. So it fits right into what he knows something about, and SpaceX could also do it for sure. And then I have this information that IK, their ambition is to have a constellation of these SAR satellites, radar satellites up with their small satellites, so they can make an image of the entire planet every hour. But that's done by small satellites, and I think they imagine their constellation should be a few hundred of those. Imagine what you can do if you have ton-heavy SAR satellites launched by SpaceX, and they have thousands of them. It will not be every hour, it will be every few minutes that they could get a high-resolution picture of the entire planet. And then we'll have data centers to chew through all that data and spit out where your enemy, you could say. I wouldn't call China is not an enemy, but it is an adversary. It's not an enemy. Russia is an enemy. North Korea, enemy. Iran, enemy. They have all threatened us with nuclear weapons, and obviously they are our enemies. They will kill us if they can. China will not kill us. They are far more civilized than these rogue countries, I call them, Russia and Iran. But we'd still like to keep an eye on China. I don't trust them. And with this system, we could keep an eye on them. Everybody in the Western world could keep an eye on them just to see where they have their military. And you could do that on a minute-by-minute basis. And that's what we could do in peacetime with such a large constellation of SpaceX satellites. We could have peace of mind by knowing exactly what our enemies and adversaries are up to at any given time on our timeline. And now I have just more sources for all the things I've said here, and so you can follow up on it and learn even more about it. And that leads us to chapter 6. How inexpensive autonomous drones will revolutionize modern warfare. So the 14th improvement I'd suggest SpaceX would make is that they make the Shahed drones autonomous, and that they make them able to identify targets and also prioritize target for destruction, and also be able to make evasive maneuvers when targeted by anti-aircraft guns. That would make them a lot more valuable to the customers of these drones for a number of reasons. But let's first see here that this ability of making the drones autonomous, it's actually not a much different problem than making autonomous self-driving cars that Tesla is working on currently. And to be honest, I don't think there is a single autonomous weapon today that is being sold globally. So nobody have done it yet. But if somebody can develop such a weapon that is completely autonomous drone weapon, it's definitely Tesla. But Tesla shouldn't do it. It should be SpaceX. But SpaceX should simply take what Tesla currently has going with their self-driving cars and then adapt it to their drones. Let's see how Tesla is doing this. I have a video here that shows what goes on behind the scene when Tesla cars drives around and basically in real time identify objects in the driving environment, and it's quite telling.
So again, we are processing individual images. There we go. We are processing just individual image, and we're making a large number of predictions about these images. So for example, here you can see predictions of the stop signs, the stop lines, the lines, the edges, the cars, the traffic lights, the curbs here, whether or not the car is parked, all of the static objects like trash cans, cones, and so on, and everything here is coming out of the net, here in this case, out of the Hydra net.
Okay, that kind of showed you that Tesla is already now able to identify all kind of objects in the real world. And of course, this was cars and lane lines and traffic lights and pedestrians and so forth. Whereas for these drones, it would have to be infantry soldiers, tanks, radar stations, infantry fighting vehicles, etc., that would just have to be identified. They could basically use the same software that Tesla used for self-driving to develop these autonomous drones. And also, I think it's a easier problem to solve autonomous weapons systems than it is to develop self-driving cars, because you have a 3D space to operate in, so you don't hit stuff. You have another dimension you can use, which makes the problem less difficult to solve. And they're also far less crowded in 3D space than there is on this 2D traffic grid, where you also have unpredictable humans and animals and vehicles driving around. It's far easier to predict the trajectory of drones and artillery and mortar rounds and rockets. And also the exact same computer that Tesla develops for their vehicles, for their autopilot system, that's currently named hardware free, and it uses less than 100 watt. That can also power this SpaceX Shahed autonomous system. And by the way, it's also the computer that Tesla is using for the development of their Tesla bot, or Optimus, I think they call it, nicknamed. So that's important, because then we have a chip that is already designed for exactly this kind of job. And it's not the same as any other computing job, because it's a neural network inference problem that needs to be solved and nothing else. And that computer they have there is exactly designed for doing that really fast at very little power consumption. So that's important. And of course, SpaceX could just buy that computer from Tesla. So how could you imagine the Shahed drone would be used in autonomous mode? Well, you could, for instance, order it to systematically fly over an enemy sector and then scan that sector for targets. And if several targets are found, then it can destroy these targets in a prioritized manner, say first radar, then jamming stations, then anti-aircraft, then tanks, armored fighting vehicles, trucks, etc. That's a pretty powerful thing, and you don't have to involve any humans in it. It's not that resource demanding. You just have to launch these drones with that order. And also the Shaheds that will not find a target, they can basically return home and be refueled for another mission. And then another thing is that's super important is that in autonomous mode, the drone will not need any radio communication or not even a GPS signal, as they can also navigate looking at maps of the landscape that they themselves can update when they come back for a mission when they haven't been used. They can basically come back with updated maps to the command center. And also, to understand how important that is, that means that even if a country like Russia, who could potentially send up nuclear weapons in space and nuke out every satellite out of order in space, they could do that. They would, of course, make an enemy of every single country that have satellites in space and isolate themselves completely internationally. But they could do it in order to ground all weapons that depend only on GPS, like, for instance, the Iranian Shahed drone that cannot navigate through landscape, looking at the landscape there. That's also a pretty important thing by making these drones autonomous. So another kind of autonomous fighting mode for this Shahed mini drone could be to protect own troops from enemy rockets, drones, and even mortar rounds when moving towards enemy position. You could actually imagine that these Shahed mini drones would circle your own troops and then look for incoming enemy fire like missiles, drones, and mortar rounds. And when they detect it, they automatically attack it in order to stop it before it hits your troops. And of course, in that connection, it's important to not have friendly fire. If you have your own attack drones flying over your head, it's important that they don't attack you. So what I suggest is that SpaceX also develop a beacon, friendly identifier beacon, so you are not hit by your own drones and weapons that automatically identify you as friendly. And such a system needs to work all the time, or you can potentially risk being targeted by your own weapons. So that's another product they could sell. So how else could we imagine that these Shahed mini drones will be used in future, where we would see that all armies will have thousands or even millions of these Shahed mini drone-like weapons on storage? I expect that eventually all infantrymen and women will be trained for about 1 week learning to maintain, launch, and control a Shahed Mini-like drone. And we have some images here where we see a drone. I found it on the internet, but the source I got doesn't say what drone it is. But it actually looked very much like the Shahed Mini, I imagine. It's a delta wing, it's electric powered, and has a propeller here to move it forward. And it's launched using a catapult, a cheap catapult system that can basically launch it. And by the time I reach the end of this slide here, I'll show you a video that shows these guys here launching it. But it should not be a difficult weapon to learn how to use. And also expect that future armies will have many times more Shahed mini drones than they got infantry, because this weapon will be the prime way to kill other enemy infantry with. Remember, it will have a warhead that spreads out like 500 tungsten bullets, so a cloud of that. And that's how it can shoot down other drones. It's also how it can kill infantry or soft targets. So it will be a weapon that will be used a lot. And basically, either you need a lot more than you have infantry in your army of these weapons, or you need more drones than your enemy army. Basically, so China and Russia combined have like 10 million of these, while NATO should have 20 million. Something like that. It'll be an arms race with it. And of course with developing the most capable versions of them. And also recall that this Shahed Mini will have a much longer range than anti-aircraft guns that only can hit targets at 2 to 4 kilometers range. These guys here fly 40 kilometers, so they can intercept incoming drones much sooner and have more time to react than these anti-aircraft guns. For instance, if the drone come in at 185 kilometers, then it only takes 60 seconds to fly 3 kilometers. That's about the time an anti-aircraft gun has to react. So it's rather important that you have these Shahed mini drones as an air defense system. And also, not only that range of 40 kilometers, but you can actually have these launch catapults with mini Shahed spread all over a country, like all over Ukraine, so you can actually engage incoming enemy drones all over your own territory and have lots of time to shoot enemy drones down or enemy missiles down. It will be too costly if you should do the same thing with anti-aircraft guns. Simply litter a big country like Ukraine that's bigger than France, litter that with anti-aircraft guns. You would need tens of thousands of anti-aircraft guns to cover the airspace, and that's simply too costly. Each of them will cost $10 million, so you can't do that. But you can do it with this launcher here that won't cost more than $1,000 in mass production, and then you can have them installed all over the country. And then the idea is that whenever a radar pick up an incoming enemy, say Russian aircraft or missile, the Shahed drone should be called up automatically to launch and intercept that threat. And then if you recall how this weapon functions, it is simply you instruct the Shahed Mini to get within 1 kilometer of the air threat, and then when it is within 1 kilometer of that air threat, it has its own active radar homing system that can see the object in the air and then home in to destroy it. That's how it should be done. And why can't it do it for further distance? Well, that would require a larger radar in the Shahed there that's not available for the space and weight that is possible. So that's why it needs to get that close. A 16th improvement that I'd suggest SpaceX should sell. They should make like a gun like this. Now I have that's a kitchen tool here. It's if you can see it, it shoots a laser and then it's take a temperature. So it's just a thermal instrument that tells me how hot my food is. But imagine you have a thing like this. You hold it like here, you have a trigger here, and then on top you have a thermal camera, and you look in that, and then you basically pinpoint an enemy target, and then when you push this trigger, then you'll get some GPS coordinates on an enemy target, and then there should be these buttons here that should be launch a mini Shahed, launch a 200 kilo normal size Shahed. If it's a big target you want to destroy, then you call one of these up, and then there should be an abort button, abort mission if it doesn't arrive timely and enemy position has changed position. Something like that, an easy to use handheld mobile thing that infantry can use and that only weighs about 3 kilo. And you could make such a thing if you in mass production. Again, you could make it for $3,000 or something. There are some optics that's expensive that needs to be great. And also this thermal camera, so it also needs, of course, to be waterproof, so you can carry it in all kind of weather. SpaceX could do that. An infantry group that moves around typically is a platoon of 12 men. I've been in the army myself, so I know it. I've been an infantry guy myself in the communications, radio, and cryptography, but that's many years ago. But still, I know a little bit about how the army operate, because I've been there. And it would be a great weapon to have a target identifier, and then you could just call in Shaheds from people behind that simply launch them, or they don't have to launch them. It's just people who are basically setting up the Shaheds in these launchers, and then it automatically fires whenever an infantry pushes the button on one of these target guns. That's how it should be done. And let's now see this video so you can see how it launches here. Oh, that's pretty good, but I think we'll stop here and then go to the next slide. So how else could the SpaceX Shaheds and spy satellites be used? Obviously, if you have tens of thousands of SpaceX radar satellite in orbit, you will know a lot about the exact position of your enemy's ships, airplanes, tanks, armored fighting vehicles, artillery, radar stations, anti-aircraft guns, etc. And you will have all that information updated globally, say every 5 to 10 minutes, and it'll be 24/7. There won't be any let up in this. So you'll basically have one big movie about the Earth in high resolution that can pinpoint where everything is. And SpaceX could sell this information to subscribing armies for, I'd say it's a global market of 10 to 15 billion US dollar annually. And there should be the same cost whether it's peace or war. It's not that you can suddenly subscribe to it if a war breaks out. It actually is very valuable in peacetime, because you will not be taken with your pants down at the toilet by your enemy if they attack. You will know exactly when they're building up an attacking force. So that's why peacetime is just as important as wartime with regard to this information. Also, we should recall that radar, or these SAR satellites, synthetic aperture radar satellites, they see equally well day and night. So you cannot hide at night, nor can you hide under vegetation. You cannot hide the tanks under vegetation as we do today, or under some military camouflage nets. That won't work with radar satellites. They see right through that. The only place you can hide is actually in warehouses that have big doors where you can drive tanks and other big trucks and stuff in and out of these buildings. But then again, if you have a video of the Earth that's updated, say, every 5 minutes, then you can simply have an AI computer identify where are all the warehouses in the world, and what is going in and out of these warehouses, so we can have an estimate of exactly what equipment is inside these warehouses, even though you cannot see inside these warehouses. And this is not just pictures of the Earth and where all the equipment is. You will have exact GPS coordinates of where all this equipment and stuff is. So that means you can actually start attacking right away if you have targets within the range of the drones. And then it's just a matter of how many drones you can launch, how quickly you can destroy these targets. But of course also the enemy will have defenses. Although, as I've said in the previous slides, normal air defenses that we have today with using missiles that shoots down airplanes, these defenses doesn't work on these drones, because we only have like 100,000 of these missiles, but we can make millions of these drones. You need other drones to combat this threat, or it won't work. And you need a lot more of anti-aircraft gun. And if you don't have enough human operators to feed drones with target coordinates, then the drones can also be launched in the future. If SpaceX takes this up, they will have built-in autonomous attack mode, so you can just launch them over enemy territory and have the drones find their own targets and destroy them. And the scale is really all that matters here. And just wanted to repeat here, you can get 1 million of these 200 kilo attack surveillance Shaheeds. That should be possible to produce those for $7.5 billion US dollars. And you could probably get twice as many Shahed Mini for the same amount of money. And how much is that? Some of you may think that $7.5 billion, that's a lot of money. But it's not when we're talking military expenses. For instance, the current war in Ukraine, it compares to about 1.5 months of Western aid for Ukraine, both civilian and military aid. 1.5 months, that's $7.5 billion US dollars spent. And also last year, 2022, the annual US military budget was $722 billion. So that would only be 1% of their budget to get 1 million of these drones. Also, compare these numbers to the remaining Russian army assets in Ukraine. I have a graph over here that shows some of the assets that Russia has in Ukraine and how many of them that has been destroyed. Something that's very remarkable is that Russia had, at the beginning of the war, they had 3,300 tanks that were operational in the entire armed forces of Russia, and now they have lost 3,255 as of 9th of February 2023. That's nearly all of their tanks. The only tanks they have left to fight with are actually newly produced tanks, which they can only make one of every day, even after they have sped up production of them, and then perhaps they can make another 2 per day from refurbishing tanks from long-term storage. But these are very old tanks, like 40 years old tanks, 30 years old tanks, that has very bad aiming equipment, also bad armor. And the new tanks Russia can build, they can't have the new aiming equipment because they bought that in the West. So they have some old aiming equipment that limit their range to 2 kilometers. But they have the new armor of a new tank. But anyway, my point here is, how many assets does Russia have actually in Ukraine? Well, they do have some armored combat vehicles. They have 7,000 of those left. They probably also have a couple of hundred tanks that they have produced that can be destroyed. And then they have, here we can see they have about 3,000 artillery pieces left in the Russian army, and most of it is deployed in Ukraine. And then they have aircraft. Not even 1,000 helicopters was operational at the beginning of the war, and now 1/3 of them have been destroyed. They had 1,400 airplanes, and 300 of those has been destroyed. So you can see, if you have 150,000 of these 200 kilo Shahed drones, you should easily be able to destroy whatever Russia has in Ukraine completely. But then you also need to destroy the infantrymen. And if you had 500,000 of these mini Shahed, I'd say that would be enough to destroy all Russian infantry also in Ukraine. So the war could be over as fast as you could launch drones if Ukraine had these drones, and there's no defenses really against them currently. But Ukraine also has no defenses against them. So if Russia is the one who gets into mass production with these drones, then they will win the war. Okay, I also want to discuss a little bit about how the introduction of a lot of autonomous drones in the battlefield, how they will affect the use of current well-known weapons. For instance, how would it affect the use of armored fighting vehicles like this Bradley here? If you have a battlefield with thousands and thousands of Shahed drones, I think we will need armored fighting vehicles for sure, because that is protecting infantry from getting killed from these mini Shahed drones that will be everywhere. So if infantry cannot hide inside an armored vehicle or a bunker, then they will run a high probability of being killed really quickly. But the kind of weapon we have on these armored fighting vehicles, I believe that's the wrong weapon for the future wars we are going to fight. Normally you have a heavy machine gun like pictured up here on an armored vehicle, that's a kind of a classic weapon. But that's not what we need. Because it cannot shoot down drones. What we really need is a very capable anti-aircraft gun with exploding rounds. And it could be this BAE 40mm naval gun that is pictured down here. And I'll show you a video of it in a little while. But that gun is super capable. And I do believe it can be fitted on top of a Bradley fighting vehicle because it's 1.9 meter high and 2.5 tons. So I think that's possible to fit on top. And if it is a little bit too big, well, then they have to make a new version of this Bradley tank that will be big enough to fit a gun like this. I can say the Bradley tank with this gun will be 3.7 meters high in total from top to toe if they do it. And I think that doesn't sound unrealistic. But what is so great about this gun is that I believe it can shoot down Shahed drones at 5 kilometers range, so better range than the 3.5 kilometers that the Gepard, German Gepard that I talked about previously could do. And this gun here is also capable of shooting down missiles. I would say that would be subsonic missiles at 2.5 kilometers away. And that means it can also shoot down mortar rounds because they're pretty slow-moving projectiles. And it has a range of 10 kilometers for slow-moving targets like a truck or a mortar position 10 kilometers out. That's an insane long range because normally these Bradley fighting vehicles, they only have this heavy machine gun has a range of like 2 or 2.5 kilometers. This one can hit targets 10 kilometers away. One issue with hitting anything 10 kilometers away is that it will require some really, really sophisticated aiming gear that will take up a lot of space. And that's why I think there should be a separate Bradley that has a powerful radar that is able to look 25 kilometers away. I believe the Gepard, the radar that was installed on the Gepard, German Gepard anti-aircraft gun was a 10 kilometer radar because it was small. And you could put a 25 kilometer radar if you had a Bradley fighting vehicle that only had a radar on top of it, and it was a control vehicle that could control other Bradley vehicles with anti-aircraft guns on it. So basically this control vehicle see whatever there is in the sky that is enemy targets and then direct either by wire or wirelessly direct other Bradley fighting vehicles to shoot them down. Then there should be, of course, on a fighting vehicle, there should also be a manual control where they have a standard thermal camera that can pinpoint targets, say up to 4 kilometers. That's what tanks should be able to hit, so that there are standard equipment for that. But if you have that kind of gun, they should also have that kind of aiming equipment, but not to see something that's 10 kilometers away. That would be too big for this if it has this gun on top as well. Okay, and I think the Ukraine war here has shown that tanks and infantry vehicles, they're very easy kills for modern anti-tank missiles. So equipping armored fighting vehicles with powerful radar-controlled anti-aircraft guns, that's a very large part of the solution to that problem that's so easy to kill a tank and an armored fighting vehicle. If they have this anti-aircraft gun on top of them, then they can stop an incoming anti-tank missile. It can even shoot down mortar rounds. And what kind of ammunition does this gun use? I have a picture down here that shows what kind of bullet it shoots. It shoots 40mm bullets, and this is the one here. That bullet here has a proximity fuse, so if it gets within 10 meters of another drone or aircraft or helicopter or a mortar round, then it explodes. And what happens when it explodes? Well, you can see it here on the picture that there are some small bullets here. These are tungsten pellets, they call them tungsten pellets, and there are 1,100 of those. So it basically busts into a sky of high velocity bullets and 1,100 of those. That's a pretty destructive weapon against soft targets like missiles and infantry. And okay, if it should be used against infantry, then this proximity fuse is probably not the fuse to use. Then it should have a timer also, where you basically said, okay, we have located some infantry people 6 kilometers away, and we have their GPS coordinates, so we aim at them and we shoot a bullet, and then a timer simply make this grenade here explode exactly when it's 6 kilometers out above these infantrymen. If it was triggered by the proximity fuse that normally would be active when you shoot at aircraft, then my fear is that it would actually detonate too soon when it comes down and see the proximity of the ground. And it shouldn't do that. It should explode a few meters above the heads of those infantry. That's how it would be most deadly. Let me show you the video now here. And I muted the sound. It's mounted on a ship because it's a naval gun. But it's not unnormal for naval guns to be mounted on infantry fighting vehicles and vice versa. Let's see that one more time. So here, dark, and look at it when it fires. Imagine that on an infantry fighting vehicles. Certainly, if I was infantry, I'd love to have that kind of gun on my vehicle. And also protect against incoming anti-tank missiles. That's really what they need. Okay, the next weapon I like to analyze in terms of how it would be affected in a future where you have lots of autonomous drones flying around is the main battle tank. Will we need these tanks in such a future? That's a question, and my answer is yes, we will still need tanks for a few reasons, but the need for them will be greatly diminished. We will not need as many tanks as we have today, probably only 1/3 of the tanks. And to understand that, my reason for that is that we need to understand what a tank does. It's the biggest gun on the battlefield. In close combat, it's the biggest gun, and that's a very important thing. But when you have Shahed drones flying around that have a warhead of 35 to 45 kilo, of which like 90% of that warhead is explosives, the rest is packaging. And that we should compare with a tank shell that is typically a 20 kilo thing when it's a 120 millimeter tank shell. That's standard NATO tank shells. But less than half of that is explosives. And the reason that there's so much steel in it is the same for artillery, that you need a lot of steel to keep the shell together when it's fired out of this gun at really high velocity, like 2,000 kilometers per hour. So you need a lot of steel to prevent the explosives in it from actually detonating, or the shell from deforming when it's pushed out of that acceleration. So with these Shahed drones, you have a much bigger bang, and that's something you can use for close combat. You can see how much would it take an infantry sitting in a armored fighting vehicles. They locate a target, and now they want that target to be destroyed. They could call a tank to do it, of course, or they could call one of these Shahed drones that could be 6 kilometers behind enemy lines, and it could be launched from ground, and then it will take like 3 to 4 minutes to arrive at the destination. And if it's already in the air, it will only take 2 minutes to get to the target when it flies at this 185 kilometers an hour. So there are only two advantages actually of keeping a tank. One is that the shells of a tank cannot be stopped by an anti-aircraft gun or mini Shahed drones. They fly too fast to be stopped. Also, it may be faster to shoot a target requested by infantry. A tank is right there on the battlefield and it shoots its shells at really high velocity. So it may be faster to destroy a target, and time is sometimes of essence. So no, I don't think tanks will be obsolete because of these autonomous drones, but the need for them will be greatly diminished. It'll be more important to have a lot of drones available. The problem with tanks, however, is that they are easily destroyed by anti-tank missiles, as has been demonstrated in the Ukraine war. And also in the future, I think they'll be easily destroyed by these 200 kilo Shahed drones. And how are these drones going to destroy these tanks? Well, you could sit in an armored fighting vehicle and use its aiming equipment to pinpoint the GPS coordinate of an enemy tank, and then you basically request a Shahed strike on that tank on those coordinates. And alternatively, an infantry who is out in the open, they could have this gun that I was talking about that SpaceX should also make with a thermal camera here, where they could aim at a target and then basically push a button, and then a Shahed will come, either a small Shahed or a large Shahed, depending on which button they press, and it will come. So I think that's how it will work. So therefore, in future drone wars, I think tanks will need to be protected by armored fighting vehicles with powerful anti-aircraft guns on them, but they also need to be protected by swarms of mini Shahed drones that can detect incoming missiles and destroy them, and also incoming drones and destroy those as well. That's the role of this mini Shahed in a defensive role for tanks and other stuff on the battlefield. Now there's one more important type of weapon that we need to discuss how that would be influenced in the future by an abundance of autonomous Shahed-like drones. And that's artillery, of course. And my expectation is that 155 millimeter heavy artillery, which is standard in NATO, can be fully replaced by an abundance of 200 kilo Shahed drones. And you may think I'm a fool for saying that, because current war in Ukraine shows that most Ukrainians and most Russians are killed by exactly this weapon. A lot of artillery is used on the enemy and it kills a lot of people. Main killer. So why can I say something as crazy as saying it won't be needed at all? Well, hear me out. I have listed now 7 reasons why the Shahed 200 kilo can overtake completely that role. And the first reason here is cost. You need to fire about 100 shells, costing about $1,000 a piece before you actually hit a target. I showed you this picture with a field littered with craters that had hit nothing, and only a few of these shells are actually hitting enemy targets. So it's quite expensive to use artillery to hit anything. 100 of these shells costing $1,000 each. That's $100,000 you spend. And a Shahed can do the job of hitting something for $7,500. And then you might say, okay, but some of those will be shot down because of air defenses. That's true. So let's make it free. So you need to spend 3 Shaheds here, and that will be $22,500 you need to spend on Shahed to get the same job done. But then again, if you have to shoot down Shaheds, then the enemy also spend resources shooting these Shaheds down. They spend ammunition on anti-aircraft gun. They spend drones that needs to target these Shaheds. So it's not a complete loss for those you actually lose. So cost-wise, I think it's much cheaper to destroy enemy targets using Shaheds than conventional artillery. Maybe I should say here that there is this one advantage about heavy artillery. They cannot be stopped by anti-aircraft guns or mini Shahed drones because they fly too fast to be targeted by these things. So that's an advantage of them. But I don't think it's enough. The other thing is time to fire. It requires more time, people, and equipment to fire 100 heavy shells with artillery rather than launching 3 Shaheds to do the same job. Note that these 200 kilo SpaceX Shaheds, they can be launched from a paved road that are everywhere, but you're just using a landing gear where they can be lined up on that road and just ready to go with somebody pushing a button to request a destruction of a GPS coordinate that has been located on some enemy targets. And the third reason here is detection of fire location. It's very easy today with radar systems to detect exactly where heavy artillery is firing from. As soon as they fire, you have a pinpointed GPS location of that artillery, and then you just send a swarm of drones to destroy these artillery guns. So I think they'll be very short-lived in a future battlefield where you have lots of these Shahed drones available to send at GPS targets. The same thing doesn't really apply for the launch of Shaheds, because you could launch them and then they can fly for a few kilometers below the radar, and then the enemy doesn't know where they was launched from. But of course, if you have airborne radar or you have satellite radar, then you can locate those Shahed where they are launched from, because you can see them from space or from an airborne radar. So, but the enemy may not have that. Russia certainly doesn't have enough radar on the battleground, and they have very little airborne radar, and they don't have satellite radar, barely, to do this job. And the fourth reason here is that you can do, with Shaheds, you can do simultaneous all-around attacks. the attack angle can be simultaneous and it can be coming from all sides. You can't do that with artillery. It comes in from one side and only one side. So all you need to protect yourself against that is the openings for your bunkers and so forth just needs to point the other way of where the artillery shells are coming in from where the enemy is located. And then you have effective protection against that. Whereas the Shahed can just fly around and then come in from behind and go right into a bunker door, or if that door is open, it can fly right in and explode inside the bunker. And also this thing about hitting stuff simultaneously. Whenever you shoot an artillery, it's a sequential thing. First you shoot one shell, then you load as fast as you can, shoot another one. But when the first shell hit, you have already warned those that you are shooting at that they have to seek shelter immediately because there will be more rounds coming in. And then it will be far less effective, that artillery strike. With Shahed drones, you can basically attack simultaneously. All of your Shaheds will be coming in at the exact same time, and boom, it will be you cannot run for cover because it will be too late. There will only be one bang, and then everything explodes. So that's another reason why Shaheds are just better at destroying the enemy. And then, of course, as how destructive are a Shahed compared to an artillery shell? Well, Shahed has this warhead of 35 to 45 kilos, of which most are TNT, dynamite explosives, whereas a standard 155 millimeter shell, it weighs 43 kilo. It's a heavy thing, but it only has 7 kilo of TNT in it. The rest is simply fuse and metal to keep that shell together when it pops out of the barrel at 3,000 kilometers per hour. It's an insane amount of metal that goes into this, and I didn't know that until I actually investigated it. I was quite surprised about it. So it's a much bigger bang, it's much more destructive a drone than an artillery shell. And then, of course, there's a range. That 155 artillery shell, most of the guns only shoot 30 kilometers, but some of the best guns can shoot 40 kilometers. And then there's an exotic Excalibur shell that has its own propulsion system built in, and it costs a fortune. I believe currently they cost something like $60,000, but in mass production you could probably get them down to $30,000 a piece. But they have even less explosives in them, because they need propulsion system and also guidance. And the Shahed has a 600 kilometers range. And understand this, if the Shahed, they still have 600 kilometers range if they're used in close combat on the battlefront and are launched from 6 kilometers behind enemy lines. Then they will have not only this warhead, 35 kilos of explosives in the warhead, but they will also have an almost full tank of gasoline. That will be 100 liter of gasoline. So it will be an explosion with a lot of dynamite and a lot of gasoline. So it will be even more destructive when it's used for short range combat. And the range of 600 kilometers is such an enormous advantage. It's an enormous advantage over traditional artillery. And then there's this thing about reusability. Whenever you shoot an artillery shell, it's over, it's done, you cannot use it twice. Whereas these drones, if they don't find a target, or the target is gone by the time it arrives, it just flies back for refueling and another mission. So it's not that you lose the ability to use it again as it is with artillery. Also, another thing with artillery is that they have all these misses, like only 1 out of 100 actually hits the target. And then there are a lot of unexploded shells that just hits the ground without exploding, but they still have this armed fuse. So now they are lying there all over the field as almost landmines. When the war is over, you have to clean all these shells out of the ground, and it's not easy because they are armed grenades that hasn't exploded. It's just cost a lot of money to clean up after the war, whereas these drones here, they can be programmed to detonate if they crash, simply to make it less costly to do the cleanup after the war is gone, or if you take enemy territory that is littered with debris from the war, it's much easier to clean up the ground. So these are my reasons why I don't think heavy artillery will be used in the future. We just used a lot of drones. It's cheaper and it's better, more effective. So I hope you were convinced by that. Okay, and now I just have some sources and attribution for previous slides as always, and you can download it if you follow the link below this video. And that leads us to chapter 7, why SpaceX should also be making drone weapons and spy satellites. There are 2 reasons I'll give, and the most important reason is that the good guys in the world, they need to have the best weapons. All the future of all of humanity will be life under tyranny rather than life in freedom. Because authoritarian regimes, as we can see it now with Russia, they do attack democracies. They do not leave them to themselves. They want more, and they don't care for the life and suffering that they will bring with it when they use military force to conquer more. So we need the best weapons to keep our own borders safe and free of these expanding tyrannies. We're not going to give them any chance to expand. We need the best weapons for that. The other reason I'll give here is it's good business, and Musk needs the profit to fund his mission for developing a sustainable civilization on Mars. And now Musk has actually been ridiculed quite a lot for having such a mission that we should colonize Mars, lately here by Bill Gates. And I believe that's very wrong. The thing is that colonizing Mars is a necessary condition, but not a sufficient one for preserving sentient life in the universe. Then you could say, well, there must be a lot of sentient life out there. We're not unique or anything. But the fact is, we haven't observed a single sign that there's sentient life out there. Not anything. So for all we know, we are alone, or we live in a simulated world, and that's why we can't see anything. Or all civilizations that have come out has gone extinct for some reason. But that's also strange. Why should they all of them have gone extinct? I think we are alone because we cannot observe anything out there. And I guarantee you, if we have a civilization that reach our level and just a few hundred years out in the future with the exponential growth we have in technology, it will be very easy to see such a civilization because they will be able to use artificial general intelligence and robots to basically transform their entire solar system within a fairly short time to something that will be easily observable from millions of light years away, because they will basically build massive computers that can create simulated worlds where they can have fun in and live, because they can create fully sentient beings inside simulated worlds. But they will need a lot of power to run that. That means they need to harvest all the energy of the solar systems they are present in. And when they do that, then the radiation from these solar systems will completely change, and that's why we can see them from our place easily. If there are civilizations out there, we can see them because they have transformed the solar system into a power production house for those computers that they're running. And that would have changed the frequency of the sunlight to something much cooler that is then radiated out. And that would not happen naturally. It can only happen if there's a super advanced civilization that occupies that solar system. So they're easy to spot, and we have spotted nothing. So that's why we most likely are completely alone. And this little spot here on this Earth, that's where all the intelligence resides, at least in the observable part of the universe. If it's infinite, the universe, then there can be lots of life out there. We'll just never get a chance to see it because we can see so far back in time and out in the universe, and then we cannot see any further for physical reasons. But I don't want to go into that here. Anyway, I think it's an enormously important mission to colonize Mars. I think Musk is completely right about it. But it's also important that the good guys have the best weapons so we can preserve freedom. I think life in freedom is a lot better life than a life in tyranny, where somebody else decide everything. And the other question we could ask is, why not let other companies make spy satellites and drones? I have a couple of reasons why that shouldn't be done. I think SpaceX can make more money if they do it themselves. And also SpaceX have the scale and resources to make this happen quickly. I think other companies will take a lot longer to do this, and that's a reason why SpaceX should do it. The expertise that SpaceX currently do not have internally in their company, they can either get that from Tesla, especially their AI system and their computers for running AI. They can simply take what Tesla has and then adapt it to drones. And maybe they should also acquire the Finnish company IK for obtaining expertise in synthetic aperture radar satellites. But otherwise, I think it's right in the alley of what SpaceX do. And then you could say another question is, why should SpaceX do it and not Tesla? Because after all, some of the technology will obviously be some technology that is already used a lot in Tesla. Why shouldn't we do it in Tesla? I have a couple of reasons here. And Musk, he owns 50% of SpaceX, but he only owns 15% of Tesla. So he will simply make more money personally by doing it at SpaceX. And he has this mission to fund Mars colonization, which is going to be insanely expensive. So I think he should just do it in SpaceX, because he'll make more money for that mission if you do it there. And the other thing is that SpaceX makes things that flies, and Tesla do not make things that flies. And the third thing is that SpaceX is already a supplier for the US military, and they have procedures and clearances in place to make top secret stuff. That might not sound that important, but all the legalities and things about this is actually quite burdensome for a company to get in order. It can take years to get these permissions to sell to the army and to have procedures that are required when you sell stuff to the army. So, and they have all that stuff running there in SpaceX, but not in Tesla. And also, I think that SpaceX should make these autonomous drones, because they can still sell these drones and prevent bankruptcy of SpaceX if Russia go rogue and decide to nuke all satellites out of space. Then you can say, why on earth should Russia nuke space and also make an enemy out of China and India that also will have their satellites destroyed by Russia if they nuke space? Why would they do that? That's not gonna happen. But the thing is that I am rather sure that by 2024 the war will still go on in Ukraine, and either Russia will build a lot of cheap drones that are dumb, they just function with GPS, or Ukraine will do it, or more likely some of Ukraine's allies will do it, and they will send a lot of cheap drones, not like thousands or 10,000, but hundreds of thousands and millions of cheap non-autonomous drones that all need GPS to function. And that will overwhelm Russian defenses if it's Ukraine who got this. And then Russia has an incentive to basically ground all these drones by nuking space and taking all these GPS satellites out, because then they can't find their targets. However, if Ukraine in 24 instead can attack the Russian army with an abundance of autonomous drones, then Russia will gain almost nothing and lose a lot by nuking space, as these drones that are autonomous, they can function regardless of whether there is a GPS system working in space or not. And they can also function without spy satellites. Of course, it will be harder to locate targets, but it can be done also autonomously, and it can also be done by humans that are studying the maps that are stored on the drones, and then when the drones return, these maps are uploaded to computers, and then humans can find targets and send the drones out to destroy these targets without any spy satellites or GPS functioning. So, in my opinion, SpaceX is the only company in the world that can bring fully autonomous Shahed drones to market in volume by 2024, perhaps by the end of 2024, and thereby decrease the risk of Russia nuking space, if that risk actually is there. But we never know. Russia was crazy enough to attack Ukraine, and they might be crazy enough to nuke space. And if SpaceX do not do it, the only drones we know that Ukraine will be able to get in volume by 2024, that will be these non-autonomous drones that any industrialized nation can build in volume if they want to. And Russia could ground all these drones if they do nuke space. I hope that SpaceX will take this up and build these drones. We need it for lots of reasons. And now, as always, I have some sources and attribution. And finally, we have arrived here at the concluding remarks, chapter 8. So in making this video, I become convinced that wars will increasingly be fought with an abundance of cheap autonomous drone weapons rather than conventional weapons like heavy artillery and tanks. This is another good reason for NATO to hurry up and donate more of its stock of heavy artillery and tanks to Ukraine. The fact is that NATO needs to replace most of these legacy weapons anyway with an abundance of cheap autonomous drone weapons, or NATO will not be able to win future wars. The Ukraine war has reminded the democratic part of the world that the risk of authoritarian countries attacking democratic countries is very real, especially if these authoritarian countries think they are strong enough to overwhelm the defense of the country they wish to assimilate. Fortunately, against everybody's expectations, Ukraine turned out to be a lot stronger and more determined to fight back against the Russian invasion. Now the war has lasted for a year, and it seems likely to drag on for several more years, because Russia is improbable to withdraw voluntarily as long as Putin is in power, and Ukraine will keep fighting as long as Russians are occupying their land and oppressing their citizens. In my opinion, the Ukraine war is most likely to end in a few more years with a military victory that either sees Russia assimilate all of Ukraine and Moldova, or Ukraine kicking the Russians back to the 2014 border when Russia started their invasion of Ukraine. A few more years of war in Ukraine is enough time for both Russia and the allies of Ukraine to get into mass production, with tens or hundreds of thousands of Shahed-like drones produced every month. That much production in a single month is doable because it's already done in automobile factories that make much heavier and more complex products than these drones. Also, we know that Russia is already building a factory for mass production of Shahed drones. In my opinion, whoever party gets to mass produce tens or hundreds of thousands of Shahed drones per month first will win the war, because it is simply impossible to defend against that many drone attacks, even if all of the world's existing stocks of anti-aircraft missiles and anti-aircraft guns are used. Therefore, it's my sincere hope that SpaceX will see this opportunity to make a lot of money and also do a profoundly good thing for people all over the world who love living in freedom and democracy rather than tyranny and autocracy. As I have argued in this video, SpaceX will be able to scale the production of Shahed-like drones faster than anybody else. SpaceX will also be able to make their drones better than everybody else, because they got Starlink for communication, and they're best positioned to make another massive constellation of radar satellites that will be able to see everything on a minute-by-minute basis globally, and that can be used for target acquisition and evaluation. However, most importantly, SpaceX can jumpstart the development of autonomous drone strike and defense capability, because they can copy whatever Tesla has developed for its autonomous driving and simply adapt it to autonomous drones instead. I have discussed how this is not a huge hurdle to overcome. I really hope that the top brass in SpaceX will see this video, because I think it's obvious that SpaceX should do this for all the reasons given in this video. You can increase the likelihood of that happening and indirectly help Ukraine in their struggle if you give this video a like vote and also subscribe to my channel. That will tell the YouTube algorithm to expose this video to many more people. Also, don't hold yourself back in the comments section. My channel is still very small, so I still got time to read all the comments, and I'm really interested in hearing what you think. With that said, thank you very much for watching this video to the end, and I wish you a healthy and joyful life in freedom and democracy.